Okay. Right. Good morning, all. Good morning. We will start. So, how is the audio and the video online ones? Let me also check from my end. It's okay, right? Yeah. What about the audio and video? It's okay, no? Right. So it seems students are still joining in. Right. I'll wait for another like 2-3 minutes and we'll start. Right. Let me share this to the group and come. Okay. Right. We'll start. We'll start. Good morning again. Okay. Okay. So first thing is now today we are going to start the revision of 2026, right? Revision class. Now, when it comes to the revision class this time compared to other times, other years actually, this is the year with the least number of months before the class, right? I mean, in if I consider 5 recent 5 years, right? Now this time we only got just 8 months for the revision program, right? So in the years before, it was more than 8 months, right? But this time it is just 8 months if the exam is happening in August, right? Now, as they have declared now the exam is going to be in August now, right? Sometimes there can be a postponement due to the postponements and delays of the A-level exam ongoing, right? But we can't expect, right? We can't expect. There's a probability that it's happening. There's a probability, but we can't expect that that is going to happen for sure. We don't know, right? So therefore, what we are planning is to have the exam in August, right? So until then, we have 35 weeks remaining. Until then, we have 35 weeks remaining. 35 weeks. Until then, we have 35 weeks remaining. So therefore, we are planning the class here for these 35 weeks, right? We are planning the class for 35 weeks, right? If it was postponed by, let's say, 2 weeks or 3 weeks or something like that, then that will be added as an advantage, right? So if there is postponed, that will be added as an advantage, right? That is how that we are going to plan this. That is how we are planning, right? So therefore, my plan is to 35 weeks, and we'll be stick to the plan during these 35 weeks. And by the end of 35 weeks of time, give me 1 second. Okay. And by the end of 35 weeks of time, then we will be at August, right? If the exam is in August, then no problem. We have already planned for that. If there is postponed, right? As an additional bonus time, we will get another 2 weeks or 3 weeks or something like that, right? Therefore, that also we can utilize for all our question papers and everything, right? Okay. Now, listen. When it comes to this revision class, there are two main types of students who are joining today, right? Who has joined today. One obviously is the ones who have already set for the exam in 25, and the ones who are doing their second attempt, right? And the other group of students here are the students who are sitting for the exam this year, but you don't have a solid foundation in some of the lessons, or maybe the initial lessons, or maybe having all the theories, you are not comfortable. You can't do questions. You are not comfortable with the lessons, right? So therefore, also 26 students are also joined, because you can get that foundation again from the beginning in the revision class, right? So first, I'll address the first group I mentioned above, right? The first group is the students who sat for the exam this year, right? Listen, first group is the students who already sat for the exam this year, right? So in their case, this is the thing. Listen, if you feel like you have done your best at the last exam, at the first try, right? If you feel like you have done your best, your maximum potential was there, and your maximum effort was there. If you feel like you have done it, right? Then which means, if you are satisfied about your level, if you are satisfied about your attempt that you have put, right? For the ones like, in that basket, in that category, I don't think you need to do the exam again, because if you have done it with your maximum effort, so know the word, just listen to the word carefully, right? What I'm saying is, if you have put your fullest effort there in the last exam, so if you are sure that you have done your best at the last exam, right? So whatever it is, that maybe you are at C level or B level or whatever it is, if you have done your best, which means your potential is already done. So therefore, in such cases, you can think twice before you are doing the second attempt, right? Because if you have already done your best, right, which means you are satisfied with it. If you are satisfied, no problem. If you are satisfied, no problem, right? Because if everyone is not going to get A passes, we know everyone is not going to get B passes, or everyone is not going to get F passes as well. So therefore, if you have done your best, which means you can think twice before starting the second attempt. Because now, if you have already done your best in the last attempt, spending another whole year is not that valuable in your case, right? Not that valuable in your case. So therefore, you are the ones who have to think this twice before taking any decision, right? And the ones who are coming for the second attempt should be the ones who didn't apply your best, who didn't put your best effort in the first time, in the first attempt, right? That is why you are here. That is why you should be here. Because now, if you didn't do your first attempt properly, if you didn't do your first attempt to your best, to your maximum, which means you have more potential of doing this. You have more potential. Since you have more potential, right? Since you have more potential of doing this, which means you can improve yourself during these years, during these 8 months of time, and then you can sit for the exam in the coming year in 26, right? With an improved version of yourself, right? So therefore, that is the exact group from 25 batch that should be here, right? So just think of yourself whether you have done your best or whether you haven't done your best in the last attempt, right? So if you have already done your best at the last attempt, which means you are already there. You are already there in the sense you have already achieved the target with your maximum effort, with your maximum potential. But if you haven't done your best, even though you have the potential, which means you haven't done your best in the last attempt. Since you haven't done your best at the last attempt, which means for all of you, for the ones who didn't do it properly in the last time, this is the second chance you have to do it, to take the exam again, right? So that is why this is 4. So therefore, first have an idea about yourself, whether you have done it properly last time, done it with your best timing, with your best version, with the best version of yourself last time or not, right? So if you haven't done your best at the last time, this chance is for you, right? So that is how you should be. Got my point, right? Okay, and now again, if I come back to that second category, listen, if I come back to that second category, if you feel like you haven't done your best in the last time, right, you have to start all the things from scratch today onwards, right? You have to start all the things from scratch today onwards, right? So which means now you know how you work last time, right? Sometimes you might be work just in the last 3 months or last 2 months, and you haven't completed the theory parts properly, and you haven't practiced papers properly, right? And you are sometimes your syllabus coverage is not that good. Such cases can be there, right? So therefore, now if you have already taken the decision to take the exam this time as the second attempt, from the first day onwards, you have to put your fullest effort and engage with the work here, right? You have to put your best, you have to put your fullest effort and engage with the work here. What's the point? Right? Give me 1 second. Because otherwise, what is going to happen is, right? Otherwise, what is going to happen is, again, you will do the second side as the first side. The same way that you do the things in the first side. That is not going to work in the second side. Right? For sure. So that is why you are here. Since you didn't do your first attempt properly. That's why you are here now. Right? So that's the ultimate point that you are here. So therefore, first thing is you have to start everything from scratch from today onwards. Right? So if you stick to the plan that we are going to conduct the program, for sure you will go through in your second attempt, right? Second attempt. Or if you are doing a third attempt by any chance, right? For the third attempt students also, this is the same, right? The thing I said is the same for your third attempt also. It is the same. Right? So therefore, even if you have not put your fullest effort in your first attempt and the second attempt, if you are doing the third attempt now, the last try, third try now, right? Which means this is the last chance you are going to have in your whole life, right? Last chance you are going to have in your whole life, the last attempt of you, right? So therefore, in terms of the criticality of the third attempt, that is the maximum. That is at the maximum. So therefore, for all the students who are taking your second attempt and third attempt, right? Don't just be like your previous attempts. Right? Start fresh here. Start everything from beginning here. Start fresh here. And you have to have a solid plan when working today onwards up until the exam. Right? So I'll be also explaining the plans and I'll be helping you out with the plans, with the study plans. Right? So I'll be giving you study plans. I'll be discussing you the study plans with you all. Right? So therefore, with the support of that, with my support, with that support, right? What you can do is you can come up with a proper plan and plan your work ahead. You can plan your work ahead. Right? Okay. And the other students who are here are, other set of students who are here are 26 students. Right? 26 batch. 26 batch students who are doing the first side. The reason that you are being here is probably that you don't have a solid understanding and a solid base about some of the lessons or the previous lessons, right? So therefore, now, which means you don't have a solid base in the previous lessons now, right? So which means for all of you also, even though you are doing your first attempt, right? If you don't know the foundations, if you don't know the initial parts, if you don't have any thorough knowledge, a solid knowledge on the initial parts, right? Now, for you also, the same thing is applicable. Start everything from today onwards, right? So, even though you are doing the first attempt, that doesn't mean that you are going to face a different exam. That's the same exam you are going to face, right? That's the exact same exam. So, therefore, right? Therefore, the same thing applies for you as well, right? So if you are doing your first attempt, which means now you have 1 year ahead of the others, right? You have 1 year ahead of the others. That's the thing, right? You are 1 year ahead. You can take that advantage, right? That is actually an advantage, because now in reality, thing is like this. Even though we have the second attempt, right? We have a chance to do the second attempt. Now, when we do the second attempt, in reality, we are 1 year late already, right? If you are doing the third attempt, we are 2 years late already. But if you do it properly, that value addition during that 1 year is very much, right? That cannot be measured in terms of money or anything. But my point, the value addition is high. Let's say now from the first side, you got this kind of a result. Two C passes and an S pass, right? So this is a result that you can apply for a university, and you can get some kind of a not average, say kind of low level of degree, right? Still you can attempt, right? Let's say now from that degree program, according to the job market that you have, you are going to open up for a salary of say 35,000, 35,000, right? And now you are doing your second attempt with your fullest effort, and you are going to end up having something like this. Say you are ending up having something like this, and you got selected to say engineering, right? Now in this case, at the very point that you are passing out also, your starting salary, just the starting salary, just the starting salary is going to be like 3-4 times of this. Is going to be 3-4 times of this minimum. This is the minimum starting salary. Minimum starting salary. Now, when you are in the job for like 2 to 3 years, these values, these numbers will be multiplied. These numbers will be multiplied. So therefore, now can you see? Now, here the difference is around 4 times. Therefore, the whole amount of money, whole amount of salary that you are going to collect throughout the year by doing this, right, can be collected just in 2-3 months, by doing this, right? So there is the advantage. So therefore, even though you are 1 year late, that doesn't matter if you end up getting a good result. If you end up getting a good result with colors, with flying colors. What's the point? So therefore, that's what I meant, that if you didn't do your best at the first attempt, right, that is why you should do your second attempt. If you didn't do your best at the first attempt, that's the reason. That's the exact reason that you should do this. Correct? Because if you didn't do your first attempt properly, which means you have the potential already. Having the potential, but you didn't do. But for sure, we know that you have the potential, right? So you know that you have the potential. Having the potential, still you didn't do. So that's the thing. Right? What's the point? So therefore, definitely you should put your fullest effort this time and go through this, right? All right. Now about the plan here in the revision class. Listen. About the plan here in the revision class. See? Right. See, our plan is like this. Our plan will be like this. Right? Permanent time for the class is this. Right? Permanent time for the class is this. It will be on Wednesdays from 8:30 to 2. Right? It will be from 8:30 to 2 on Wednesdays. Permanent time is here. Right? Regular class. Regular class is on Wednesdays. Wednesday, 8:30 to 2 p.m. Right? This is a regular class. Then in January, listen, in January, next month onwards, we are starting a reverse class parallel to this. Right? We are starting a reverse class parallel to this. Reverse class in the sense, I'm going to take the units we have without having much links with the previous lessons. Right? Previous units actually. without having much links with the previous units, and we are going to cover them from the reverse direction, from backwards, from the reverse direction, right? So that is the reverse class. That is the reverse class, right? Dates are not confirmed yet, and this will be January onwards. This starts January onwards, right? For the students who are registered for the revision class, this reverse class will be free, right? For the students who are registered for the revision class, the reverse class will be free, which means now you are going to have 2 classes per week, the regular one and the reverse class, right? Because now we are planning for a 8-month period. We are planning for a 8-month period. Therefore, the amount of work you have to do during a week is very much higher compared to other times, other years we had, right? So that's why for the target of covering the syllabus before 2-3 months, say 2 months before the exam, right? Having that plan, I'm planning on this, the reverse class, right? So therefore, that will be 2 different lessons in 2 classes. In the regular batch, there will be a different unit, and in the reverse batch, reverse class, there will be another different unit, right? So it will be 2 different units in 2 different classes, right? That's the second one. Reverse class, that is January onwards. That will be happening January onwards. And the next one is the paper class, right? Now, if you are doing a second attempt or third attempt, for sure you know that what's the importance of writing papers before the exam, right? For sure you have an idea about the importance of writing papers before the exam, right? So therefore, practicing with the exam standard papers, practicing with the advanced questions, not the simple ones, advanced questions with thinking sides, with the analytical sides, is going to play a major role here, right? It is going to play a major role here. So especially if you are doing a second attempt or third attempt, you know this. Sometimes you might be having all the theories in your hand with you, but yet you can't tackle questions, you can't do questions, right? So such things are there, such cases are there. Therefore, as you have theories in your hand, right, it is very much important that you are doing papers, you are practicing with papers, question papers at the same time. Got it? So therefore, now we have our paper class. We have our paper class for 26 batch, and that is already ongoing. And for the revision students also, revision students and the reverse class students who are going to join in January for the reverse class, there can be students who are joining just for the reverse class as well, right? All of you, right? You can write papers here. All those papers are exam standard papers, and most importantly, once you write the paper, you can get the graded paper by the next week, right? So which means you can get an understanding about your current level. You can get an understanding about your current level, where you are, and you can see the trends, how you are going to increase your mark, and what are the potential points that you can, potential areas that you can improve the marks, right? So therefore, both of them are very important, writing papers and as well grading papers. Grading in the sense having the mark paper. Both the things are very much important. Both the things are very much important, right? So therefore, writing papers is mandatory if you are doing the second attempt, doing the exam this time, because if you are doing second or third attempt, which means you haven't done it properly in your first attempt. That's the thing, no, in your previous attempts. That's the thing. So therefore, if you haven't started papers yet, right now here we will be starting this in our paper class, and paper class is on Mondays, I mean discussion. Discussion of paper class is on Mondays. Huh? Discussion is on Monday from 8:30. Sorry, from 6:30. From 6:30 to 10. 6:30 to 10. Right? 6:30 to 10. And this is extendable up to 10:30 in the coming months. Right? This is extendable to 10:30 in the coming months. Right? For now, the allocated time is 6:30 to 10. When you are writing papers, you can write papers at our paper centers. Paper centers are the two institutes that I conduct classes. Right? When you are writing papers, if you are writing the paper physically, you can write the paper at Lisa Institute, Horana, from Monday to Thursday. And you can, if you are writing the paper at Maxima Bambalapedia, you can write the papers on Monday and Tuesday in Maxima, right? And discussion is happening on Monday. Discussion is happening on Monday, right? So that is how the paper class is going to be. That is how the paper class is going to be, right? And for online students also, listen, for online students also, you have the chance to write papers as online from Monday to Thursday, right? From Monday to Thursday, everything is done through the website, right? Now, since today is the starting day, I have opened the session, right? So therefore, the YouTube live is also going on and the Zoom is also open, right? But in the coming weeks, to join the class, it can be done through the website only, right? So if there are new students here, so this is the website, this is the LMS website. Through this only, you can join classes and all the things related to the class will be done through the website only. All the things related to the class means first thing is joining the class, right? First thing is joining the class. And second thing is accessing recordings, right? Accessing recordings. And third thing, writing exams, right? And fourth, the evaluation of exams. Evaluation in the sense, the final marks of exams. Everything will be updated on the LMS, right? So therefore, for all the things, everything will be done using the website only, right? That is an LMS, that is a LMS, not just a website. That is the LMS. So you can visit the website, visit the LMS, and you can do your registration and you can get enrolled to the class and you can join class, access recordings, and if there are any soft copies of the tutorials are provided, you can download all the soft copies there, right? And everything is done through this, right? And about the tutorials and study materials for online students, your tutorials are posted by the second week, and you will get your tutorials to your doorstep to the address that you have mentioned when enrolling to the class on the website, right? So therefore, make sure that your correct living address is mentioned there, correct? Make sure that your correct living address is mentioned there on the website, because what we will be doing is we will be taking all addresses of the registered students from the LMS and going to post all your tutorials to the address you have mentioned there, right? The reason to say this is sometimes there are some students who are you are entering different addresses to what you are living, right? So therefore, now what happens is if you do so, what I'm posting the duties to the address that you have mentioned there, right? So once that is posted, if you didn't get the duty, since you are living in a different address, right? Now from my side also I have sent the duty, and from your side you haven't got the duty, and it is stuck somewhere in between. Sometimes I will get the return duty after 2-3 weeks, because if it is not delivered, what happens is we are getting the return again. We are getting the return tute again, right? But no point of doing that, which means because from my side also, that is totally a waste of time and money and everything, right? Because there is a cost component involved in the tute and the delivery. So therefore, no point if you are not getting the tute, right? No point of doing that if you are not getting the tute. No? That's why. So therefore, make sure that you are mentioning your correct living address. Make sure you are mentioning your correct living address there. Got it? And in any case, if you have changed your living address, right, you can inform me and you can do that update here on the website again, right? So in any case, if you have changed your address, if you have changed the address, so as the first thing, inform me that, sir, we are going to change the address next month onwards, and say this is the new address. And then I'll instruct you to update that address here on the website again. So therefore, then you can do that update. Then you can do the update. Correct? So that is how it should be. That is how it is going to be if you are an online student. Right? Okay. And other than this, in weekly basis, right? Listen, in weekly basis, you are going to write one or two questions just to recall the things that we have done in the previous week, right? They are called the recall papers, right? Recall questions or recall papers. Recall papers. Recall papers means, listen, recall papers means from the next week onwards, I'll be giving you a very small test of 30 minutes before starting the class to recall what we have done in the last day. Because then only we can make sure that you are on the track for today's work. Because this is a 6-hour class, no? This is a 6-hour class. Since this is a 6-hour class, right? If you are not aligned to the class from the beginning, which means again you are not going to get the maximum out of this. Right? This is a revision class. So therefore, compared to the theory class, the speed of delivery here will be faster. It is higher. Speed is higher compared to a theory class. Because this is a battle in just 8 months. This is a battle in just 8 months. So therefore, when you are writing something, when you are drawing a diagram, if you are doing a simplification, in terms of everything, speed of your work should be higher, right? You have to do these things faster. You have to do the thing faster. Got the point? So therefore, if you are already in my theory classes, if you have been in my theory classes, or if you are already in my theory classes, definitely you will see a clear difference between the speeds that I do in the theory class and here. Obviously, that should be. Obviously, that is how it should be. Because here we are starting this from scratch, just 8 months ahead of the exam, and theory class is something that we are starting having more than 2 years ahead of the exam. Right? What's the point? So simply that is 2.5 years before the exam. Right? That is 2.5 years before the exam for a theory class. For 26 batch, the time duration was not exactly 2.5 years, but it is 2 years and 3 months of time, because you had your O levels in somewhere around April or something, no? Right? April or May or something. And we started the class, I think, in June after your O levels. Right? After your O levels. So therefore, in your case, you have a kind of a lesser time compared to 2.5 years. Right? For the other coming up batches, the usual time you are going to have for A-level exam is 2.5 years. That is 2.5 years. Right? Okay. So therefore, the speed will be a little bit higher compared to other classes. Right? And so what I was explaining is the recall papers. Recall papers is for recalling the things that we did in the last week at the last week, during the last day, right? So therefore, to write the recall paper, it's a must to go through the last week workings that you have done, right? It's a must to go through the last week workings you have done to write the paper, right? Then without going through the last week things, you won't write this paper here. So therefore, that is why I have introduced recall papers to encourage you to go through everything and come to the class with a prepared mind, and the prepared version of yourself. Correct? So then you can be here, you can write the paper, and with the discussion you can get an idea about how you did, to which extent you did, right? Okay. And then other than that, in the revision class also we are going to have the spot exams, right? So in my theory classes, you know, we are conducting spot exams, right? Spot in the sense they are impromptu exams. They are impromptu in the sense they are sudden exams, right? Spot exams. Spot means they are not announced before the exam. They are not announced before the exam. They are sudden exams. Spot exams, impromptus. We call them impromptu. Listen, we call them impromptu. They are impromptu exams. Sudden exams, impromptu exams, right? Therefore, spot exams will also be there. On a random day, you will be facing a spot exam, and for spot exams also, we are not going to spend much time on spot exams, because anyway you are writing full papers here in the paper class, right? You are writing the full papers in the paper class. Spot exams are exams designed for maximum 1 hour duration, right? Maximum of 1 hour duration, based on a particular lesson, or it can be based on a particular unit, right? Something like that, based on a particular unit or based on a particular lesson. Now, as an example, let's say now we have covered Newton's laws in a particular week. Then there's a probability of that you are getting a spot exam from Newton's laws, something like that. Say we have covered gravitational fields on a particular day, then you will be getting the spot exam from gravitational fields, right? And those exam papers are designed for maximum 1 hour, right? So they can be varied from 30 minutes to 1 hour, spot exam papers, right? So spot exams are also there. So basically, this is the plan here we have in the revision class. And other than this, to cover your structured essays, practical sessions, right? To cover the practical sessions, we'll be conducting practical seminars, right? I'll be conducting practical seminars to cover practical sessions, right? And for 26 batch, for my theory batch that is ongoing already, one practical session on mechanics is already done, and the feedback that I got from the students was very much kind of a satisfactory one, very much satisfactory. And I was planning to have the second practical seminar last week, right? From waves, but with the disaster we had in the country, we had to postpone that, right? So actually we planned for the last 2 weeks, right? I was looking at the last 2 weeks of the month for the waves practical seminar, and institutes were also okay, but finally the flood disaster came, and therefore I had to call off it again, and sooner it is going to happen. So likewise, from unit wise, right? As unit wise, we'll be doing the practical seminars. And finally, before the exam, again, I'm going to conduct a main practical seminar to cover all guest practicals using a single seminar, right? So therefore, practical seminars are also coming up. Practical seminars, there are two types of practical seminars. One is the ongoing seminars based on units, unit based ones, unit based practical seminars. And before the exam, you are going to have the practical seminar with the guest practicals and the most important practicals from, out of all 38 practicals on a single day. That will be the final practical seminar, and that will be the main practical seminar we are going to have, right? So in that way, we are going to cover the structured parts as well. We are going to cover the structured parts as well, right? And when you are writing papers here, listen, when you are writing papers here, in each paper you have structured essay questions. In each paper you have structured essays. So which means you are practicing to write structured essay questions in a weekly basis. You are practicing all question types in a weekly basis, right? So therefore, that is very important. That's what I told you at the beginning also. Just knowing the theory is not enough. Just knowing the theory is never going to work in A-level exam for any subject, not just for physics. For other subjects also, that is the same. Not knowing only the theory is not going to work. So therefore, writing papers is mandatory. Right. Okay. So I think that is clear. So if there's anyone, if there's anyone who have any doubts regarding the work plan or anything else, I'll give you a time now. Quickly ask your questions. Right? All good? What about the online students on Zoom and on YouTube? What about you all? Are you all clear? Okay. Right? Put a thumbs up at least if it is clear, the ones on Zoom and the ones on YouTube. What about you? All good? Right? Okay, then we'll start the workings for today. Right. So today we'll be starting off with linear motion because we are going to start unit 2 at once without doing the unit 1 in the revision. Right. And for the unit 1, we'll be taking a separate day and I'm going to conduct unit 1 with a different plan, right? So today we are starting mechanics, and in this revision class, listen, in this revision class, we are not going to cover all the units in the same order, right? This is a revision class, so therefore I'll be covering the easier lessons somewhat before, and likewise I have a different plan. So today we are going to start off with mechanics. We are going to start off with mechanics. What I meant was, now after mechanics, right? After mechanics, don't expect that we are going to go in the same order as mechanics, waves, then optics, then heat means thermal physics, gravitational fields, electric fields. Don't expect it, right? So always I'll be taking the easier lessons to cover first, right? Okay, so we'll be starting off with mechanics. Put the heading as mechanics. 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 And in mechanics, we are starting linear motion today. In mechanics, we are starting linear motion today. Right? We are starting the linear motion today. Right. Now, since this is the first day, you might not have the tute with you. I mean, the online students, right? Online students, you might not have the tute with you. So until you get the tute in the next week, right? For today, I'll be sending you the soft copies of the tute for online students, right? Because since this is the first day, right? I don't have the exact list of registrants by the first day, because now after the first day, after this phase only, most of the students are going to enroll or register to the class if you are comfortable with the class. So therefore, since this is the first day, I don't have any chance to post them off now, right? So therefore, just be patient. This is the first day, and for the first day, I'll be sending you the soft copy of the tute, right? To get the soft copy, oh good, okay. To get the soft copy of the tute, drop a message to this number, and then you will get it. Right? That's my usual number. Put out WhatsApp, this number, and then you can get the tute. Right? Listen now. Listen now. Linear motion. Listen. Linear motion. First thing is, what is a linear motion? First thing is, what is a linear motion? Right? Simple as that. First thing is, what is a linear motion? Simply, linear means that is a straight line. Linear means a straight line. See how these words are broken down? Linear motion. Linear means a straight line. Right? A straight. Straight. Linear means a straight. Right? So any motion, any object which travels, which undergoes in a linear path or in a straight line is called a linear motion. Simple as that. That doesn't matter whether it travels with a uniform velocity or an acceleration, increasing acceleration, decreasing acceleration, constant acceleration, or deceleration, increasing deceleration, decreasing deceleration. That doesn't matter. As long as the object travels, travels in a straight line, as long as the object travels in a straight line, that is called a linear motion. Very simple as that. So any motion which travels in a straight line is a linear motion. Very simple. Very simple. Okay, write down below. Write down below. A motion which takes place. 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 A motion which takes place along a straight line. Along a straight line. A motion which takes place along a straight line. Along a straight line is called a linear motion. 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 Right. Listen. To study about linear motion, we have linear motion parameters. Right? Parameters means variables. Right? If you are a combined math student, probably you might have heard the word parameters. Right? If not, the other students, bio students, just know that parameters means variables. To study about the motion, we need variables, because when an object travels from one point to another point, so we know there are different physical quantities. There are physical quantities which are getting changed. What's the point? Now, as an example, if it travels from here to here, so we know it takes some time. And it travels with the velocity, and it has an acceleration. So likewise, and from here to here, it covers a distance. Since there is a straight distance, there is a displacement. So likewise, listen, when it undergoes in linear motion, to study about the linear motion, we have to think of the parameters. To study about the linear motion, we have to think of the parameters. What's the point? Linear motion එක ගැන කතා කරන්න නම් ඒකේ parameters ගැන අපි දැනන් ඉන්න ඕනේ. Parameters දන්නේ නැතුව linear motion එකක් කියන්නේ මොකක්ද කියලා අපිට කියන්න බෑ. Linear motion එක study කරන්න බෑ. You can't study the linear motion without knowing parameters. What's the idea? You can't study a linear motion without knowing parameters. That's the thing. Parameters දන්නේ නැතුව linear motion එක ගැන කතා කරන්න බෑ. Parameters ටික දැනගෙන ඉන්න ඕනේ. So therefore, we have parameters. How many parameters we have in linear motion? Right? How many parameters? There are 5 parameters in a linear motion. Right? So let's see what these 5 parameters are. And based on these parameters only, all the linear motion equations are built up. Based on the parameters only, all the linear motion equations are built up. Alright. So write down parameters of linear motion. Parameters. Write down. Parameters of linear motion. Parameters of linear motion. Parameters of linear motion. Right. Write down one by one. First one. Initial velocity. U. Right. These are the symbols, standard symbols. And second one, final velocity. V. Third one, linear acceleration. We also call it acceleration. Simple A. Fourth one, displacement. displacement. Right? Notation is S. And 5, time interval we denote by T. Right? T is not the time, there is time interval. There is not the time. Time means the present time. No. Now, as an example, time means, say now it's 9:40. 9:40, that is time. Right? Now, if the motion continues from 9:40 to 9:45, the time duration, time interval is 5 minutes. That is what it should come here. Time interval, or we call time duration. Time interval or time duration. That is what it should come here. That is what it should come here. Time interval or time duration. Okay. Take down. Take down. Take down. Right. Yeah. Mm-hmm. Okay. Right. Listen. Now, using these parameters, linear motion equations are built, because without having equations, we can't study the motion. We can't solve the things. We can't find the parameters in a motion. Right. So therefore, there are something called linear motion equations. How many linear motion equations we have? We have 4 linear motion equations. In physics here, listen carefully. In A-level physics, we don't prove the linear motion equations, because you only have to use the equation and try questions. But if you are doing combined maths, you will prove all 4 linear motion equations in combined maths. Right? So since we don't have the proof, I'm not going to do the proof. Right? Okay. Write down next. Linear motion equations. Next. Linear motion equations. Linear motion equations. Linear motion equations. Write down. Linear motion equations. Linear motion equations. Right. Look at the board. Look at the board. Now, Using these parameters, these four linear motion equations are proved, right? These four linear motion equations are proved using the parameters. See, first one, let me write here, V equals U plus AD, first linear motion equation. Next one, S equals UT plus half AD squared, right? And third equation, V squared equals U squared plus 2AS. And last linear motion equation, S equals V plus U over 2 whole thing into T. These four are called linear motion equations. So which means we only have four linear motion equations in the world, right? So in the world, we only have four linear motion equations. There are not more than four. There are not more than four. That's only four linear motion equations in the world, right? Listen. So which means any linear motion question that you are going to solve is solved using these four equations. Is solved using these four equations, right? So that is very straightforward. If you know these equations and if you know how to apply the equations, right? And if there is a linear motion question, right? All the linear motion questions, whatever the type of the question that is, any linear motion question is solved using these four equations only. Using these four equations only, right? Take it down. Take it down. Take it down. Right. Okay, all good. Right. Okay, now listen. I'll explain the application of the equations using a question itself. Right? Go to the first question in the root. Go to the first question in the root. Right? Go to the first question in the root. Now there are space given in the root itself. So where you can do, right? Space is already given along with the question, right? That you can utilize for the questions. The given space, right? Question one. Question one. Go to question one. An object starts its motion at rest and gain the velocity of 10 ms minus 1 within 4 seconds. Determine its acceleration. Determine its acceleration. See? Now, listen. When you apply linear motion equations, before the question, listen. All linear motion equations are vector equations. What are vector equations? Vector equations are the equations which has vector quantities in it. So therefore, all linear motion equations are vector equations. They are vector equations. Since they are vector equations, all rules regarding vectors are applicable, right? What are the rules regarding vectors? When we are applying an equation, we have to have a considered direction, right? We have to have a considered direction, right? If you are applying the equation, you have to have a considered direction. And based on that considered direction, we have 4 rules, right? First one is the vectors which are acting along the same direction of consideration, are considered as plus, and vectors acting along the opposite direction of consideration are considered as minus, and vectors acting perpendicular to considered direction are neglected, and vectors acting inclined to considered direction should be dissolved into components. Those are the vector rules. All vector rules are valid, right? All vector rules are valid when you are using linear motion equations. And a linear motion is also applicable for a selected section only, for a given section. What's the point? Okay. Write down in red before the question. Write down this point in red. Write down in red. Write down. All linear motion equations are vector equations. 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 Next point. Therefore, all basic rules regarding vectors. Therefore, all basic rules regarding vectors should be followed. All basic rules regarding vectors should be followed. All basic rules regarding vectors should be followed. When using equations. All rules regarding vectors should be followed when using equations. Okay. Mention vector laws one by one. First one. Write down. Vectors acting along the same direction of consideration. Vectors acting along the same direction of consideration. Vectors acting along the same direction of consideration. Are considered as plus. Plus means positive. Are considered as plus. Vectors acting along the same direction of consideration are considered as plus. Right? Are considered as plus. Same direction means plus. Second one, vectors acting along the opposite direction. Vectors acting along the opposite direction of consideration. Vectors acting along the opposite direction of consideration. Vectors acting along the opposite direction of consideration are considered as are considered as minus. Negative are considered as minus. Third point, vectors acting inclined to direction of consideration. Inclined vectors acting inclined to direction of consideration should be dissolved into components. Should be dissolved into components. Should be dissolved into components. Last one, vectors acting last one, vectors acting perpendicular to vectors acting perpendicular to direction of consideration. Vectors acting perpendicular direction of consideration are neglected. Vectors acting perpendicular to direction of consideration are neglected. Right? Vectors acting perpendicular to direction of consideration are neglected. Right? So, in a nutshell, this is what I meant. Say if there is same direction to the consideration, right? Now, always these directions are with respect to the considered direction. No? With respect to the considered direction. Considered direction is any direction that you can consider. You have the right, you have the freedom to consider to serve your requirement, to satisfy your requirement. Right? So, therefore, if you are interested about the say horizontal rightward direction, then you can select, you can choose that horizontal rightward direction for the application. Got it? So likewise, considered direction is not a given direction. There is a freedom we have, right? And we should be clever enough to choose the correct direction as the considered direction to serve our target, to serve your requirement, right? So in a nutshell, this is what I meant. Say if there is same direction plus opposite direction minus inclined, you have to dissolve into components. Perpendicular, you have to neglect, right? Now, if needed as a summary, you can mention this as well. If needed as a summary, this is a summary of all the sentences, all the points that I mentioned before in words, right? So if needed, you can take this down as well. All right, now let's go to the question. Question 1. Right? Now, for the question 1, since there is a simple question, sometimes you might not need a diagram. But my advice is to, my recommendation is to have a diagram, have a small sketch from the first question onwards, because we are going to start from the simple question, that is true, but we will be moving towards all the advanced questions by the end. So therefore getting practice to the diagram is mandatory. Getting the practice of drawing a diagram is mandatory. So therefore, from the very first question onwards, you can draw the diagram. First one, an object starts a motion at rest and gained a velocity of 10. See, something like this. Start from rest. U equals 0. Initial velocity is 0. If there is starting from rest. And now it travels. and it has gained a velocity of 10 no? Gained a velocity of 10. Then it has gained a velocity of 10 during within 4 seconds. This is how we mention time in a linear motion. The point where the motion starts is called t equals 0. The point where the motion starts is called t equals 0. The point where the respective section of the motion ends is the t equals 4 seconds now, because it is during 4 seconds, right? That is during 4 seconds. And from u to v, we know acceleration is rate of change of velocity. Very simple. Acceleration is rate of change of velocity. If there is a change of velocity, which means there is an acceleration. If there is a change of velocity, which means there is an acceleration, right? For sure. Then from here to here, the system is, the object is accelerated. So label it as A. And then pick the correct equation. Let's say these points are A and B. So likewise, you can mention the section. Then mention that section here, like this. From A to B, and you have to mention your selected direction. Selected direction means, what is selected direction? Selected direction means that is the considered direction. That is a considered direction. Since my motion is from left to right, I have considered the rightward direction. And pick the correct equation out of these four. Right? U is known, V is known, time is known, we need acceleration. So the correct match is V equals U plus AT. V equals U plus AT. V is 10. See, this is how you should substitute. V of this section, this is like this. You are applying from A to B, no? So A is the initial point, A is initial. And B is the final point. Initial velocity is the velocity at the initial point. Final velocity is the velocity at the final point. 0 plus A times time is 4. Time is the time duration. T equals 4 minus T equals 0. That is 4. Right? So how this came is, this is actually 4 minus 0. 4 minus 0 is 4. Right? Simplify this. 10 equals 4A. A equals 2.5 ms minus 2. Acceleration of this object is 2.5. Acceleration of the object is 2.5. Got it? Right? So likewise, you have to have a small diagram, right? And their section should be labeled and pick a correct direction, a required direction, and apply a suitable equation. Right? Simple as that. Take it down. And if you have any questions, feel free to ask. If any questions, feel free to ask. Right? right? Okay, write down below with a red pen. Write down below with a red pen. Linear motion equations can be applied. 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 Linear motion equations can be applied to a considered section. To a considered section. To a considered section linear motion equations can be applied to a considered section. Can be applied to a considered section having a common acceleration. Having a common acceleration. Common slash constant. Having a common slash constant acceleration. Having a common slash constant. A common slash constant acceleration. Having a common slash constant acceleration. Having a common slash constant acceleration. Right. Okay, let's go. Second one. Go to second question. Question 2. An object is released at rest under gravity. Right. So have a diagram. Listen. If an object is released under gravity, it undergoes gravitational acceleration. Right. Any object which released under gravity undergoes gravitational acceleration. Only the gravitational acceleration. Right. So therefore, we know the motion of the object is vertically downwards, and when it comes vertical downwards, it undergoes gravitational acceleration, right? Anything which is at the surface of Earth, right, in this atmosphere, undergoes gravitational acceleration only, right? Okay, then the diagram is like this. Question 2. You can try the question with me. You can try the question with me. And it is released from rest now. It is released from rest. U equals 0. U equals 0. Released from rest. An object is released at rest under gravity. Determine its velocity after 4 seconds of fall. Now let's consider this point as the initial point, t equals 0. And after 4 seconds of fall, no, then this is 4 seconds. T equals 4 seconds. Right? Velocity after 4 seconds. We need velocity. Then I'll consider this velocity after 4 seconds as v. I'll consider this velocity as v, right? And the fallen height of the after 4 seconds, fallen height after 4 seconds, fallen height is from here to here. See, if I mark the fallen height, that is from here to here now. See, let's mark it as h. This is a diagram. This is a diagram. Now, apply a suitable motion equation from here. Try quickly and send your answers quickly. I'll start in 2 minutes. Try quickly and send your answers. I'm going to start in 2 minutes. Quickly. I'll start in 2 minutes. You can send your answers, online students also. Doesn't matter whether you are on Zoom or YouTube. I can see both. Right? I can see both. Send your answers. Shani, 40 ms minus 1, right? Others? I will start in a minute. Right, now the time is enough. Let's say I'll label these sections as A and B again. Right? So first one is from A to B. We need velocity now. Right? From A to B, we need velocity. So I'll apply downwards. Mentioning the direction is a must. Right? So if you apply the equation without mentioning direction, no marks will be given. Because this is a vector equation. This is a vector equation, very critical. Right? So V equals U plus AD. Final velocity in this section is V. Initial velocity of the section is U, 0. Plus, this travels downwards with gravitational acceleration. Direction of gravitational acceleration is always vertically downwards. Direction of gravitational acceleration is always vertically downwards. That is always vertically downwards. Right? Now my considered direction is also downwards. Considered direction is also downwards. So therefore, this is a plus G. Plus G means plus 10 and value of G is considered as 10. Value of G is considered as 10. So therefore, this is plus G 10 times time is 4. Right? Simplify this. V equals 40 ms minus 1. V equals 40. To find H, apply another equation from A to B. From A to B, vertical downwards, right? I'll be using S equals UD plus half AD squared. You can use any equation, doesn't matter, you can use any equation because now since V is also known, applying V squared equals U squared plus 2AC is also possible, and applying S equals E plus U over 2 times C is also possible, right? Since you know this, right? Then S is H, U 0. When U is 0, the product UT is 0 plus half G is 10, T squared is 4 squared, right? 2, 10 over 2 is 5, 4 squared is 16, 16 times 5 is 80, that is 80 meters, 80 meters, 80 meters, right? That is how the application goes. That is how the application goes. Correct. It's clear enough, right? Clear? So today we are going to finish off linear motion, right? So therefore, stay vigilant in the class, be mindful in the class, and carefully understand these things from the very beginning, right? So using today itself, we are going to finish entire linear motion, na? We are going to finish entire linear motion by today. Okay, go to question 3. Go to question 3. Question 3 and send your answers. I'll start in 2 minutes. Go to question 3 and send your answers. Right, any answers? Question 3. It says a ball is released under gravity at rest. What's the ratio among distances covered within its first second? There's a small typo. Listen. Within its first second, sorry, it should be first comma, second and third seconds of motion. The comma is the typo. It should be within its first, second and third seconds. Should be like this. First, comma, second and third seconds. This is how it should be. First, second and third seconds. First, second and third seconds. Right? So if you draw the diagram, it's something like this. Release from rest. U equals 0. Release from rest. Right? And it undergoes under gravity. Right? Say this is T equals 0. Say this is T equals 0. And first second is up until T equals 1. First second is up until T equals 1. Second is up until T equals 2. Third second is until T equals 3. Third second is until T equals 3. Right? So the distance covered during the first second is this one. Distance covered during the second of motion is this. Third second of motion is this. Right? First second, second and third second. First second of motion, second of motion and third second of motion. 0 to 1 is the first second. 1 to 2 is the second. 2 to 3 is the third second. Right? So we need the ratio of distances covered during these three. Covered during these three. So it is like, say this is S1 and this one is S2 and this is S3. So what we need is S1 to S2 to S3 ratio. S1 to S2 to S3 ratio. What we need is that S1 to S2 to S3 ratio. Right? This is what we see. S1 to S2 to S3. This is what we need. Right. I'll start in a minute. Any answers? Afil, 1 to 3 to 5. Good. Afil, good. Right. See, I will do this way. I will do this way. I will do something like this. Now, I'm going to break this down as sections as A, B, C, D. A, B, C, D. Right? And since there is a motion under gravity, since there is a motion under gravity, throughout the motion is gravitational acceleration G. That is gravitational acceleration G. Right? Throughout the motion. Throughout the motion, that is gravitational acceleration. Now, since only the initial velocity at point A is known, I'm not going to apply any equations for the sections like B to C, C to D, something like that, because the reason is, if I choose a section as B to C to find S2, first hand I need velocity at B. First hand I need velocity at B. Without knowing velocity at B, you can't find S2. So therefore, I'm going to approach the question in kind of a different manner. See, first, finding S1 is easier. So therefore, first I'm going to apply an equation from A to B, downwards. See, first equation from A to B, downwards, A to B, downwards, is equals ut plus half AD squared. Right, S is S1, U is 0, half A is 10, this during 1 second, 1 square. Simplified, that is 5 meters. That is 5 meters. S1 is 5 meters. Now, to find S2, I'm not going to use the equation from B to C because I'm not going to use the equation from B to C because I don't know the velocity at B. To apply this equation from B to C, if the section is from B to C, initial point of the section is B and final point of the section is C, then velocity at the initial point of the section should be known, but velocity at B is unknown. So therefore, without doing it, I'm going to do something like this. From all the way from A to C, we can use an equation all the way from A to C. Then I'll get the total height fallen during first 2 seconds. Right? Since the height fallen in the first second is known, if you subtract that, this part remains. See? Then for the second one, equation is applied from A to C downwards. A to C vertically downwards is equals ut plus half AD squared. Then SC is going to be S1 plus S2. SC is going to be S1 plus S2 both. Because from A to C, no, S1 plus S2. U is still 0 because my section is A to C and A becomes the initial point still. A is still the initial point and C is the final point. Right? Then plus half G is 10, T is 2 now, 2 square. 2 square. Right? Then what you are getting is, now S1 is known. Plug that value, 5 plus S2. 5 plus S2 equals 5 times 4, 20. See, S2 is 15 meters. S2 is 15 meters. This total displacement is 20. From that total, if this 5 is subtracted, this part remains, that is 50. That is 50. Right? Next one. Similar approach from A to D all the way, I'm going to use the equation. A to D all the way from A to D downwards is equals ut plus half AD squared. Right? Then S will be S1 plus S2 plus S3, but still U is 0, 0 plus half G is 10, T squared is 3 squared. Simplify this, then S1 plus S2 plus S3 equals 45. Right? We know S1 is 5 and S2 was 15 plus S3 equals 45. So S3 equals 25 meters. S3 equals 25 meters. S3 equals 25 meters. right? What we need was this ratio, no? What we need was this ratio. Then S1 to S2 to S3 is 5 to 15 to 25. This is divisible by 5. Then 1 to 3 to 5. The final answer is 1 to 3 to 5. Final answer is 1 to 3 to 5. Right? So it's very good that if you have got the answer by your own. Right? The point I want to give in this question is, if acceleration is constant, if the acceleration is same in sections, you can consider multiple sections at once as well. Right? So yeah, at that point also, in the previous point also, I mentioned that in red. I mentioned the same point in red with the previous point. Right? Same idea. If the acceleration is constant, you can apply it for multiple sections at once. Take it down quickly. Take it down. Forward your questions if there's any. Forward your questions if there's any. Okay, write down below with a red pen. 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 If acceleration is constant, 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 in all sections, if acceleration is constant in all sections, if acceleration is constant in all sections, equation can be used, equation can be used, equation can be used, equation can be used considering multiple sections. Equation can be used considering multiple sections. Equation can be used considering multiple sections at once. Considering multiple sections at once. Equation can be used considering multiple sections at once. Equation can be used considering multiple sections at once. Okay, let's go. Next one. Go to question 4. Go to question 4. It says a bus starts its motion at rest from bus stop A and travels with uniform acceleration of 5 ms minus 2 for 6 seconds. Now travels with uniform velocity for another 4 seconds. Different sections, now different sections. Draw a diagram and try it out. At this point, brakes are applied in order to stop the bus. The next bus stop, at next bus stop B, which is 100 meters away. Okay. A hint is also given. If that's a uniform velocity, acceleration is 0. That is something we know. That's a hint I have given. Because acceleration is rate of change of velocity. If there's no change of velocity, there's no acceleration. If there's no change of velocity, there's no acceleration. Right? Okay, few parts are asked. First, draw the diagram and start it part by part. Start it part by part. 2 minutes. 2 minutes again. 2 minutes. Right? Question 4. Send your answers if you have finished. Oh. The bus starts its motion at rest from bus stop A. Now, A is a given point. A is a given point. Now, don't use A again for your workings because A is given. Right? So, this bus starts from point A. This bus starts from point A. Right? So, this is our t equals 0. Right? This is our t equals 0. T equals 0. And this is point A. Right? And it says travels with uniform velocity, and travels with uniform acceleration of 5 ms minus 2 for 6 seconds. Right. Then during 6 seconds, then until t equals 6, it travels with a uniform acceleration of 5 ms minus 2. Right. So which means at this point, definitely it should have gained the velocity. Let's say v. Should have gained the velocity. Say v. And now it travels with uniform velocity for another 4 seconds. Then from here to another 4 seconds, it travels with uniform velocity. Another 4 seconds means until t equals 10. Until t equals 10. If that is a uniform velocity, if this is v, at this point also, the velocity is same, that is v. That's a uniform velocity, no? That's a uniform velocity. And then at this point, brakes are applied in order to stop the bus. At next bus stop B, which is 100 meters away. Okay, at this point, brakes are applied. Fine. This bus stop is 100 meters away from this point, 100 meters away. And that is given as point B. That is given as B. This was given as bus stop A. If that stop, which means final velocity at this point has to be 0. If there is a stop. Right? Okay. Then only A and B are given. For my reference, I'll be labeling these two as C and D. I'll be labeling these two as C and D for my reference. Right. So that's a diagram I expected. Any answers for the first one? Determine the maximum velocity gained by the bus. Identify the scenario given, identify this story given, and looking at the diagram and everything, tell me at which point the maximum velocity of the bus is gained. What's the point? At which point the maximum velocity is there? At which point? Tell me. At which point it has the maximum velocity? A O, C O, D O, B. Quickly. Yeah, it is C. It is C because from C to D, that is a uniform velocity. So therefore, maximum velocity is gained at C, and up to D, that is a uniform velocity. After D, it decelerates. It decelerates. So therefore, maximum velocity is at C. Right? So find it out. Mention the section properly. Then for first one, what is the section now? From A to C. From A to C, horizontally rightwards, you can use any equation. From A to Z, horizontally rightwards. We need the velocity now. Time is known. Then V equals U plus AD. V equals U is 0 plus A is, this U is 0. It is given in the question. Right? Plus A is 5. Time is, time is 6. Time is 6. So V is 30 ms minus 1. Maximum velocity is 30. Second one. Travel distance in uniform velocity. Travel distance in uniform velocity. Uniform velocity is from C to D. Uniform velocity has occurred from C to D. Uniform velocity is from C to D. Right? Then apply an equation from C to D. From C to D. Horizontally, you need a distance now. Distance. Then S equals UD plus half AD square. S from C to D is, I'll label it as SCD. S from C to D, SCD. Right? And U, now my initial point is C. Yeah? Now for this section, for this selected section, C is the initial point and D is the final point. C is the initial, D is the final. Right? So velocity at initial point is V. V is 30. 30 and time duration from C to D is 4 seconds. Plus there is no acceleration from C to D. There is no acceleration from C to D. There is no acceleration from C to D, which means A is 0. If A is 0, this whole term is 0. Right? So SCD is 120 meters. 120 meters. Part 3. Part 3. Find the deceleration of the bus. So you know, deceleration occurs from D to B, no? Deceleration occurs from D to B. Right. Since we are going to find the deceleration, I will mark this deceleration as A. I'll mark this deceleration as A. Right. So no need to mark it as minus A. Right. Mark it as A and let that minus sign come. Let that minus sign come. Then you can make sure. Whether it's a deceleration or not. Right. So therefore, let the minus sign come. මුලින්ම minus sign එක දාන්න එපා. Minus sign එක දාන්න නැතුව ඉන්න දාලා නිකන් හදන්න. Then let it come. If you get the answer along with the minus sign, which means that is a deceleration. Right? Okay, part 3. Distance is known and velocities are known without time. If time is unknown, now section is from D to B. From D to B, but time is unknown. Since time is unknown, use the equation V squared equals U squared plus 2As. This is the only equation we have without time. Right? V squared is V dash squared, that is 0. 0. U squared of the section is V. U is V because this is the initial point of the section now. This is the initial and this is the final. Right? Then that is 30 again. 30 squared plus 2A, distance is 100. Take it to the other side, minus 2A times minus 2A times 100. Minus 2A times 100 equals 30 times 30. 0 to 0 cancels. A equals minus 9 over 2. So A equals minus 4.5 ms minus 2. Deceleration is 4.5. See, so it comes along with the minus sign. That's the indication, that's a verification we have as there is a deceleration. That's the verification. So therefore, let that verification come. Let that verification come. Don't apply the signage for the quantity you are finding, you are determining. Let it come. Let it come. Oh. Send your answers. Last one. What's the distance between two bus stops A and B? Any answers? Distance between two bus stops A and B. Right. Now, distance from C to D is known. No? So therefore, finding the distance between A to C and C to D is, sorry, A to C and D to B is the only requirement. Right. So therefore, first from A to C, from A to C, from A to C, in this direction, I'm going to use an equation. Right. Time is known. No? S equals UD plus half AD squared. SAC. SAC is U is 0 plus half. Acceleration is 5. Time is 6. 6 squared. So it gives 90 meters. 90 meters. And then find the distance from D to B. Apply another equation from D to B. Horizontally rightwards. Right? So again, there are multiple equations available. There are multiple equations. That is given, no? No need to find. D to B is given. That's it. D to B is given. That's it. So therefore, total distance between A and B is, see, therefore, SAB is this part plus SAC plus SCD plus SDB. SDB. These are total. These are total. Right? SAC is 90 and this is 120 and this is given as 100. Right? 220, 310, right? (310 meters). Distance between two bus stops is 300. Now listen. We can't use an equation at once from A to B. What's the reason? You can't use an equation from A to B at once. You can't use an equation from A to B at once. The reason is acceleration is not constant through sections. Now compare this with the previous question. In previous question, acceleration of sections through sections were constant. So therefore, applying for multiple sections is also possible. But now accelerations are different. Since they are different, you can't use multiple sections at once. Right? I hope it's clear. Take it down quickly. Right? If you have any corrections, do the corrections quickly. If any corrections, do the corrections quickly. Right? Write down below with the red pen. Write down below with the red pen. Equations cannot be applied for multiple sections at once. Write down in red. Equations cannot be applied for multiple sections. Write down in red. Equations cannot be applied for multiple sections at once. Equations cannot be applied for multiple sections at once. Since acceleration is different from section to section. 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 Okay. Go to next question. Go to next question. Question 5. Start question 5. Start question 5. It says a ball is thrown vertically upwards with an initial velocity u under gravity. U. Now, if values are given in labels, listen before starting the question. If values are given in labels, no need to plug numerical values, which means you can keep G as G. No need to plug G. No need to plug G. Right? If that is given in labels, we keep all answers in labels. If the question is given in numbers, we are converting all values to numbers. That is how it is. Right? Okay, first one, what's the maximum height reached by the ball? What's the velocity of the ball when it returns to the starting point? What's the total time taken by ball to return to? Okay. Right? I will also start in 2 minutes. Start now. I will also start in 2 minutes. Start now. Right? Question 5. A ball is thrown vertically upwards with an initial velocity u under gravity. Right? And a ball is thrown vertically upwards from somewhere in the ground. Vertically upwards, u. This is our t equals 0. Right? So we know if it's thrown vertically upwards, it reaches a maximum point and comes back. It reaches a maximum point and comes back. Right? That's along the same straight line. So our is to segregate these two back and forth motions. We are keeping a small space here and drawing the path. Right? We are keeping a small space and drawing the path. Otherwise, that is coming back in the same path. This is just for our ease of segregating. Ease of segregating. So the maximum height reached is here. Maximum height is here. Right? First question is about maximum height. No? Maximum height reached is here. So we know at the maximum point, if it doesn't go further upwards, listen, if it doesn't go further upwards, which means there's no velocity for that object. Right? Because if there is a velocity, there should be a motion. Now at the maximum point, there is no motion above that point. There is no motion beyond that point, right? Which means there is no velocity at that point. So therefore, velocity of the object at this point, velocity of the object at this point is 0, right? That always happens at a maximum point. That is why that point becomes the maximum point, since there is no other velocity, right? Since there is no any other velocity, it becomes a maximum point. That's the idea, right? So I'll label these sections as A, B, and C. Okay, any answers? Any answers? If you got any answers, send it here. Right? If you got any answers, you can send it here. Maximum height, any answers? Time is enough. Maximum height. Maximum height. U squared over G. 2G. Okay, let's see. Right. To find the maximum height, apply an equation from A to B, because maximum height occurs from A to B. No? Maximum height occurs from A to B. From A to B upwards is equals UD plus half AD squared. Sorry, maximum height. Time is unknown. Upwards, V squared equals U squared plus 2AS. V squared equals U squared plus 2AS. Right? V squared is 0 squared 0. U squared is U squared. Now we are using the equation upwards. I'm considering the upward direction. But we know G is downwards. G is vertical downwards. If G is vertical downwards, this should be 2 times. Now G is vertical downwards, so minus G. Vector rules. Right? I discussed before. So this is coming from vector rules. This is coming from vector rules. Vector rules. Times H. Take this whole term to the other side. 2GH equals Q squared. We need H. H is U squared over 2G. U squared over 2G is correct. U squared over 2G. Right? U squared over 2G. Second one. Second one. What's the velocity of ball when it returns back to starting point? Velocity of ball when it returns back to starting point. Now, since velocity at B is known, from B to C, we can use an equation at once. Right? Second one. From B to C. From B to C, we can apply from B to C. Downwards, right? You need the velocity. Time is unknown, but H is known. H is known, right? Then V squared equals U squared plus 2AS again, downwards, right? So let's label this velocity as, right? I'll label this as X. Velocity at point C as X, right? Then V squared is X squared. U squared is 0 plus 2 A is G. Now we are using the equation downwards. So if there is downwards, there is plus G times S. S is H. Right? So X squared equals 2GH. H is here, U squared over 2G. H is U squared over 2G. Now what happens is 2G to 2G cancels, which means X squared equals U squared. So X equals U. X equals U. The idea is this returns back to the same starting point with the same velocity that you have projected it upwards. It returns back to the point with the same velocity it projected upwards. Right? It comes back with same U. It comes back with same U. Comes back with same U. Right? This is the proof. X equals U. Right? Return velocity is also U. Third one, what's the total time taken to bowl? It should be actually taken by bowl. That's a small typo there. Make that correction. What's the total time taken by bowl to return back to starting point? Taken by bowl to return back to starting point. Part 3. Time taken by bowl to return back to starting point. Right. So easiest way to find this out is, so we know acceleration in both sections throughout the motion is constant, no? Which means considering multiple sections at once is also possible. You can consider multiple sections at once. Therefore, I'm going to use an equation from A to C at once. From A to C at once. From A to C at once upwards. Say C equals UD plus half AD squared. Right? So, if I consider the total motion, entire motion from A to C, there's no vertical displacement. No vertical displacement because this displacement moved upwards and this comes backwards again at the same point. At the same point again, no displacement. So therefore, S becomes 0. S becomes 0. U is U and total time is here T plus half. But since I'm applying the equation upwards, this is not G, that is minus G. T squared. We can take this minus sign to the front, then take it to the other side, which means half GD squared equals UT. Right? 1T to 1T cancels. Subject T from here to U over G. So therefore, total time taken for the motion is 2U over G. Total time taken for the motion is 2U over G. Total time taken for the motion is 2U over G. Total time taken for the motion is 2U over G. Right? Right? This point is kind of important. Since starting and final points are same, there's no vertical displacement. Right? Take it down quickly. That I'll mention in the note. Right? Take it down quickly. Of U square over 2G. Yeah, it's correct. Good. Right? Write down below with a red pen. Write down below with a red pen. Vertical displacement from A to C. Vertical displacement from A to C. Write down. Vertical displacement from A to C. Vertical displacement vertical displacement from A to C, vertical displacement from A to C, vertical displacement from A to C is zero since initial and final points are same. Since initial and final points are same. Since initial and final points are same. Vertical displacement is zero since initial and final points are same. Since initial and final points are same. Since initial and final points are same. Right. So go to question 6. Go to question 6. It says a bus B starts its motion at rest from point O with an acceleration of 5 ms minus 2. At the same time means at the same instance, at the same time, a car C passes point O. A car C passes point O with a uniform velocity of 10. It passes point O with a uniform velocity of 10. Right? How long it takes the bus B to overtake the car C? Right? How long means the time is asked. Time is asked. Right? Now, as an addition to the question, we will find the time and velocities at the meeting point both. Right? We will find both. As an addition, we will find both. Right? Have a diagram. Now, two objects are involved. Two objects are involved in the question. So be careful with the diagram. And first, draw a proper diagram and try it. And this is the first meeting question you are going to discuss. You are going to see. Right? In all other questions we did, there was only one object. Now here onwards, there are more than one object. Here there are two objects. They are going to meet. Question 6. Question 6. A bus B starts its motion at rest from point O. Right? So I will consider this as point O. Right? And say this is the bus. The bus starts a motion from point O. Bus starts a motion from point O with an acceleration of 5 ms minus 2, and that is at rest. U equals 0, and this starts a motion with the acceleration 5 ms minus 2. Right? And at the same time, a car C passes point O. This is B. This is given as B. And say this one is the car C. It says it passes the point at the same time. Now this T equals 0. Same time duration. It passes with a velocity 10 ms minus 1. It passes with a velocity 10 ms minus 1. How long it takes a bus to overtake car C, right? So if they are meeting each other, meeting is at the point where displacements are equal, right? Give me 2 minutes. Start this. Right. So if two objects are meeting, if two objects are meeting, physically they has to be at the same point at the same time, right? Physically, without being at the same point at the same time, two objects can't meet. Now, as an example, let's say, listen, as an example, let's say you are going to meet someone else. You are going to meet someone, right? So if you are meeting someone, both of you has to be at the same point at the same time, no? Say I'm going to meet one of my friends. If we are meeting each other, we have to be at the same point at the same time. That's the idea. So therefore, both of us has to be at the same point at the same time, right? Similar thing applies here. Then B and C should be at the same point at the same time. They should be at the same point at the same time, right? So let's say the time spent is T, then T equals T. And I will label this point as, that is not given, no? Only point O is given. So I'll label this point as, say, point P. 2 points O and P, right? Then displacement covered by the bus from here to here is, say, SB. Displacement of bus from here to here, SB. And displacement of car from here to here is, let's say, SC. Displacement of bus is SB and displacement of car is SC, right? If displacements are equal only, they are going to meet each other. That's the logic. Therefore, first I'm going to find these displacements. First, my target is to find these displacements. See, first one for B. For B, you can use an equation from O to P, no? For B, right? From, see how we apply this, from O to P. So B from O to P, right? Horizontally rightwards, if we need displacement, apply S equals UD plus half AD squared, right? S from here to here is SB for the bus, SB. Initial velocity of the bus is 0. Half acceleration of the bus is 5. Time consumed from T equals 0 to T equals T is T minus 0 T. That is T. So SB is 5T squared over 2. I will label this as equation 1. I will label this as 1. Right? Then you can do the same for C. You can do the same for C. Do the same for C. Again, from O to P. From O to P again. Horizontally rightwards. Again, same equation, S equals UT plus half AD squared. SC is SC. Initial velocity at the point is V. V is 10 now. 10t. But there is no acceleration here. It says clearly that it passes with a uniform velocity of 10. It passes with a uniform velocity of 10. Uniform velocity. No acceleration. Which means this is 0. This part is 0. So SC equals 10t equation 2. SC equals 10t equation 2. Right? Now set our logic. This is the argument. Since SB equals SC, at meeting point, then you can say SB equals SC. SB is here and SC is here. Plug those values and find it out. 4 seconds. Good. Fail. 4 seconds. Good. Very good. Fail. Good. Others? Right? SB. Now, if this argument is stated, then hereafter the question is nothing. Just plug these values. 5t squared over 2. 5t squared over 2. SC is 10t. SC is 10t. T2, T cancels, right? And 5 times 2, simplify, T equals 4 seconds, right? 5 times 2 here, T equals 4 seconds, right? That's a logic. That's a logic. And in addition to what is asked, let's find out the velocities as well, because it says it's going to overtake, no? Right? If they are overtaking, the body, the object that is going to overtake the other object should have a higher velocity, a higher speed. Then only an overtaking can happen. What's the point? Now what has happened is now they are at the same point. They are at the same point. To check whether they are actually overtaking at the very next point, right? For sure, they should overtake because that is asked in the question, right? I'm going to explain something additional. To make sure that they are overtaking, I'm going to check the velocities as well, right? The object with the higher velocity at this meeting point will overtake. Object with the higher velocity at the meeting point will overtake, right? Okay. Then let's find these velocities as well. Find it out. Consider this as VB and consider this velocity as VC. And tell me what is VB and VC? What are the values? What are the values for VB and VC? Quickly. Right? Any answers? Not yet. That's an easy one, no? Find VB and VC. If you need velocities, what you can do is apply V equals U plus AT for B. Time is known. Time is known now. Time is 4 seconds now. For B, horizontally rightwards, V equals U plus AT. Right? VB equals 0 plus 5 times T is 4. VB is 20 ms minus 1. VB is 20 ms minus 1. Similarly, for C, rightwards, V equals U plus AD. Right? This part is 0 because there is no acceleration. Very straightforward. So therefore, VC equals 10. VC equals 10. Right? VC equals 10. See? Now that's what I said. If they are overtaking each other, right? The object that is going to overtake the other should have a higher velocity at the overtaking point. The object that is going to overtake the other should have a higher velocity at the point of overtaking, at the overtaking point. That is what I proved here. See, which means now bus is having higher velocity now. Bus is going to overtake the car. Bus is going to overtake the car. Right? Take it down. This is something additional for the question, for what is asked in the question. Take it down. Take it down. Right? Write down below with a red pen. Write down below with a red pen. Write down this logic below with a red pen. If two or more objects are meeting each other, write down in red. In red. If two or more objects are, if two or more objects are if two or more objects are meeting each other, if two or more objects are meeting each other, if two or more objects are meeting each other, if two or more objects are meeting each other, they should be at the same point. They should be at the same point. They should be at the same point. At the same time. They should be at the same point. At the same time. They should be at the same point at the same time. They should be at the same point at the same time. Second point, keep using red. Second point, keep using red. Keep using red. Second point. The object with higher velocity at the point of overtaking. The object with higher velocity. The object with higher velocity. The object with higher velocity at the point of overtaking. The object with higher velocity at the point of overtaking passes slash overtakes the other object. Passes slash overtakes the other object. Passes slash overtakes the other object. Right. Question 7. Go to question 7. Go to question 7. It says a motorcycle stops at a color light and starts its motion with a uniform acceleration of 4 ms minus 2. 1 second later, another car starts to move from the color light with a uniform acceleration of 6 ms minus 2. 1 second later, another car starts. Right. Determine the time taken by car to catch the bike, distance from color light to the meeting point, and velocities of each at the meeting points. Right. So in that question, velocities and displacements are also asked. Right. Start now. And now times are different. You can see starting times are different. Right. So at the meeting point, they should be at the same point at the same time. But starting times can differ. As an example, let's say both of us, two of us are going to meet somewhere, right? And I'm coming from my home. Say it takes 30 minutes to come from there to the meeting point, and for you, you take say 45 minutes to come from your home to that point. Then our starting times are different. If we plan to meet at 12, right? I'll be leaving the home at 11:30, but you have to leave the home at 11:15. Two different initial times, but we are at the same point at the same time in order to meet each other. Right. Right. Question 7. I'll start the discussion in 2 minutes again. Question 7. a motorcycle stops at the color light and starts motion, right? So I'll consider this as the color light, and let's say this one is the motorcycle. I'll label motorcycle as M. Motorcycle M stops at the color light now, which means initial velocity of the motorcycle is 0, right? And starts the motion with an acceleration of 4 ms minus 2. 4 ms minus 2, right? And 1 second later, another car. Now the times are different. So very critical now. So let's assume this is t equals 0. Let's assume this as t equals 0. Let me mention here. This is t equals 0. If 1 second later, if this car starts 1 second later, say, see, it should be t equals 1 now. 1 second later means this is when timestamp is 1. T equals 1. It starts a motion with a uniform acceleration 6. Initial velocity of the car is also 0. So it has an acceleration of 6 ms minus 2. 6 ms minus 2. Now, somewhere down the line, they meet each other. Somewhere down the line, they meet each other. Right? So let's say at t equals t. So if they are meeting each other, both of them should be at the same point at the same time. Right? Let's say M is here and C is here at t equals t. Right? So somewhere down the line, they meet each other. Somewhere down the line, they meet each other. Right? This is the diagram. This is the diagram. Then the time spent by motorcycle is from t equals 0 to t equals t. Time spent by the car is from t equals 1 to t equals t. Right? Then you can get the correct time duration. Right? You can get the correct time duration as final time minus initial time is the time duration. Final time minus initial time. That's the time duration. Right? Simple as that. Okay. Then let's say the displacement of M from here to here is Sm. Displacement of car from here to here is, say, Sc. Sm and Sc. Right. Right. Try it out. Try it out. Any answers? Any answers? No one? No one yet. Right. Then first application is for motorcycle. Let me label these points as A and B. Nothing is given now. I'll label these points as A and B. From A to B, my first application is for M. For M, this direction S equals UD plus half AD square. S equals UD plus half AD square. S from here to here is Sm. Sm. U is 0 plus half A. A is 4 now. And time of the motorcycle is t equals t minus t equals 0. T minus 0 is t. So that is t squared. So this one is Sm equals 2t squared. We'll consider this as equation 1. Then do the same. Do the same for C. For car. Right? Do the same for C. S equals UD plus half AD squared. Right? S from here to here is SC. SC. Initial velocity is 0 plus half. Acceleration is given 6. Now, this is the important thing. Time. This time is from t equals 1 to t equals t. Final time is 3. Initial time is 1. So, time duration is t minus 1. Time duration is t minus 1 whole thing squared. Right? So, this is the difference. This is the difference. I will put some asterisk marks here. T minus 1. T minus 1. Which means SC equals 3 times t minus 1 whole thing squared. T minus 1 whole thing squared. This is equation 2. Right? Now, if they are meeting each other, again the logic is same. They should be at the same point at the same time. If they are meeting each other, they should be at the same point at the same time. Right? Should be at the same point at the same time. State your logic. State your logic and simplify. State your logic and simplify. State the logic. Since, right, again, they should move from here to here and here to here to meet, right? Since SM equals SC at meeting point. SM equals SC at meeting point. SM is 2D squared and SC is 3 times t minus 1 squared. Right? Simplify this and find the time. First question is time, no? Time taken by car to catch the bike. Right? Car to catch the bike. Simplify this. Now here a quadratic equation is coming. Listen. Here a quadratic equation is coming, which means you have to find the roots of that quadratic equation. Find the roots of that quadratic equation. And finally, what is asked is the time taken by car to catch the bike. The time taken by car is not t actually, that is t minus 1. So therefore, final answer should be t minus 1. Time taken by car is t minus 1, no? From here to here, time taken by bike is t. But car is from 1 to t, that is t minus 1. Right? So that we can do finally. If t is known, t minus 1 is known, no? Right? Find t quickly. No answers yet. 20 ms minus 1 VD. Oh, that's for the previous one. Okay. Simplify it. Simplify it. 2t squared equals, we know this is, if you simplify this bracket, t squared comes minus 2t plus 1 comes, right? So you know this is like a minus b squared. A minus b whole thing squared is a squared minus 2ab plus b squared. No? Same thing. Same thing. Right? Then 2t squared equals 3t squared minus 60 plus 3. 0 equals t squared minus 60 plus 3. This is the quadratic equation we have. Find roots. To find roots, so easily you can put this to the roots equation. Right? Roots equation. What is the root equation? If roots are x equals minus b plus or minus root b squared minus 4ac. over 2a, right? Put that in the equation. Then t equals minus b means minus 6, right? Plus or minus root b squared minus 6 squared minus 4, a is 1, c is 3. Whole thing over 2 times a. Whole thing over 2 times a. Equals, this is 6 plus or minus, inside the bracket, 36 minus 4 times 3 is 12. 36 minus 12 over 2, right? So which means it is 6 plus or minus root 36 minus 12. 36 minus 12 is 24. That is 24 plus or minus 24 over 2, right? So we know 24 can be written using the perfect square of 4, right? Then 6 plus or minus, this can be written as 4 times 6, right? Over 2. Root 4 is 2. So this is 6 plus or minus 2 root 6. 2 root 6 over 2. Now this is divisible by 2. 2 times 3 and 2 cancels. Right? So two answers coming here are, right? I'll be writing here. Two answers coming here are t equals 6 plus or minus root 6. Right? 6 plus or minus root 6. Root 6 should be determined. Then two answers are t plus root 6 and t minus root 6. Right? Someone, root 6, what's the value? Now, if you don't know root 6, what you can find it out is, how you can find it out is, we know root 6 can be written as root 2 times root 3. Both root 2, root 3 are known values. So, I have told you before, so in the other classes, if you were in my other classes, I have told you. If not, just know that you have to know these 3 root values, right? You have to know these root values. I'll mention here for your reference. Root 2 is 1.414 and root 3 is 1.732 and root 5 is 2.23, right? Now, if you need root 6, easily root 6 can be determined. Root 6 can easily be determined as root 3 times root 2. Root 3 times root 2 is root 6, no? So, from that, find root 6. Find root 6. Find root 6. What's the value? 2.45, right? 2.45. It's coming as 2.449, right? So this is coming as 2.449. We can round it up for 2 decimals. So that is 2.45. That is 2.45. So t is 6 plus or minus 2.45. So two answers are t equals 8.45. 8.45, right? 6 plus 2.45 is 8.45, no? 8.45 or t equals 6 minus 2.45. 6 minus 2.45, what's the value? 3 point, sorry, this is 3, right? 3, not 6, 3. Yeah, thanks for raising it out. 3, okay. Because here I cancelled it off with this thing. Then 3 minus 3 plus 2.45 is 5.45. 5.45 seconds or 0.55 seconds. Now still we have two answers. You can't reject any answer yet. You can't ignore any answer yet. So still we have two answers. Now go to the first question. Determine the time taken by car to fetch the bike. Time taken by car is not t. That is t minus 1. No? So I'll erase this part. We'll erase this part. So therefore, see, therefore, time taken by car. We know time taken by car is t minus 1. Right? Now, two answers are coming with respect to these two. T minus 1 is either 5.45 minus 1, 4.45 seconds. Or T minus 1 is 0.55. 0.55 minus 1. This is a negative value. This is a negative value. This is a negative value. 0.45. No? Now only you can reject this. Since this is a negative value, this cannot be a time. This cannot be a time. This is called a sign of contradictory. No need to write anything. Just draw the sign. Sign of contradictory. Contradictory means this is not acceptable. This answer is not acceptable for this given scenario. Right? So therefore, this answer of T is also not acceptable. Right? So final answers are time taken by the car is 4.45 and T is 5.45. Right? So that is how you should deal with this if you got a quadratic equation. Take it down quickly. Right? So when a quadratic equation comes, simplification is a little bit advanced and the simplification is a little bit complex, and you have to pick the correct answer from the two answers you are getting, because that's a quadratic equation. Definitely you are getting two roots after the simplification. So pick the correct one. Pick the correct one. Write down quickly. Write down quickly. Right. Second one. Distance from color light to the meeting point. Those distances are equal now. So you can use either SC or SM to find the distance. We had two equations before. Right? If you need to get the distance, get it from a proved equation before, from 1. So as 1 I had, SM equals 2t squared now. SM equals 2t squared. Simplify this. 2 times t is 5.45. This will be the distance from color light to the meeting point. Right? From color light to the meeting point. 5.45 squared. 5.45 squared. That you should find out. Right? 5.45 squared should be determined into 2. 59.4. It is coming to 59.4. 59.440 actually. 40 meters. 59.40 meters. Next one. Velocities of each at the meeting points. Same as before. Same as before. Velocities of each at the meeting point. Same. That is very easy. Find it out. For simple limb restriction, V equals U plus AD. Right? So let's say these velocities are Vm and Vc. Vm and Vc. Then Vm equals U is 0. Right? U is 0 in both cases. No? U is 0. Acceleration is 4. 4 times t. T of this one was 5.45. So EM is 21.8, right? 21.8. Then for C, V equals U plus AD again, right? VC equals U is 0, A is 6 times. But time for the car is not 5.45, that is 4.45. That is 4.45. Right? Because time spent by the car is not T, that is T minus 1. Time spent by the car is not T, that is T minus 1. 4.45. 25.8, right? 25.8 ms minus 1. Right? So therefore, car is going to overtake the bike now. Car to catch the bike, yeah. Car is going to overtake the bike. Take it down quickly. Take it down. Take it down quickly. Right? The idea I wanted to give you from the question is, if a quadratic equation comes, right, only one answer will be your correct pick. Then you have to wisely pick it out. Right? If both answers are positive, without having a proper logic, you can't pick it out without having a proper logic. Right? If there's a logic, only you can do it. So therefore, argue with the logic and you have to ignore. You have to ignore one answer, neglect one answer. Right, finished? Any questions on this? Or is it all clear? Students, any questions on this? Or is it all clear? Any questions on this? Or is it clear? Clear. Okay, let's move on. Next one. Last calculation from linear motion. Last calculation before the graphs. Right? Go to question 8. Go to question 8. Go to question 8. But not it should be A is thrown. A is thrown. Make this correction. A is thrown vertically upwards with 20 ms minus 1. And at the same time, B is released from rest 10 meters above the ground. Right. So have a diagram. A is projected. Upwards. A is projected upwards with 20 ms minus 1. Right? And at the same time, this is T equals 0, let's say. T equals 0. At the same time, another object here, B is released at T equals 0 at the same time. 10 meters from ground. 10 meters above ground. Right? What is the time taken to cross each other? Right? What is the time taken to cross each other? Now, if we think of these two motions, A travels upwards, and it will reach its own maximum point and it comes back. This is the motion of A. And motion of B is it travels downwards. Right? And somewhere in between, they will meet each other. They will cross each other. Somewhere in between, they will cross each other because A is projecting vertically upwards while B is coming downwards. So somewhere in between, they are going to cross. They are going to meet each other. That's the argument. So let's assume the meeting point as this. Argument is same. They should be at the same point at the same time in order to meet. They should be at the same point at the same time in order to meet. Should be at the same point at the same time in order to meet. Right? Right. Right. Then let's label the displacement of A up to meeting point as SA. Displacement of A up to meeting point is SA. Displacement of B up to meeting point is, say, SB. Right? SA and SB. Right. Now, if they are meeting each other, this is my argument. Listen and look at the board. If they are meeting each other, they should be at the same point at the same time. Initially, A was here, B was here. Now, at the meeting point, they should be at this line. Then, initial separation was 10, no? That initial separation equals SA plus SB at the meeting point, no? See, from the diagram, that is very clear. Initial separation of 10 meters is equals to SB and SC, the sum of SB and SC. Right? So since I need to build up that argument, my first idea is to find SA and SB. Right? Find SA and SB. Right? For SA, for A, right? Let's label these points as this one as P. Say this is P, and the meeting point is Q, and maximum point is R, and this point is, let's say, S, and his last point is T. Right. Then for A, from where to where? From P to Q. For A, from P to Q, upwards, S equals UD plus half AD squared. S is SA. U is 20, 20D, 20D. We are using the equation upwards. So this is gravitational acceleration acting downwards minus 10, right? Minus 10 T squared. Then SA equals 20D minus 5T squared. We'll label this as equation 1. Right? And do the same for B. For B, downwards. It comes from B to which point? B to Q. It comes from B to Q. Right? From, sorry, not B, S to Q. Ne? From S to Q. From S to Q. Downwards, S equals UD plus half AD squared. Right? S is SB. U0 half G T squared. SB equals 5D squared, equation 2. Now again, you can state our logic. Right? Since SA plus SB equals 10 meters at meeting point. If you don't have a correct diagram, right, you will stuck when you are writing these arguments. You will get stuck when you are writing the arguments if you don't have a correct diagram. So that's why I encourage you to show the diagram from the very beginning. Diagram is mandatory. Having the diagram is mandatory. Very important. Very important. SA and SB equals 10. SA plus SB equals 10. Plug these values. SA 20D minus 5D squared. 20D minus 5D squared plus SB is 5D squared equals 10. These two cancels. 20D equals 10. T equals 0.5 seconds. 0.5 seconds. So for the first one, answer is 0.5 seconds. 0.5 seconds. Second one, maximum height reached by A. That's the same question that you have done before. Maximum height reached by A. For A, from P to R, right, upwards, V squared equals U squared plus 2A's. V squared is 0, U squared is 20 squared plus 2, but G is minus 10 H. Take it to the other side, minus 20 H equals 20 times 20. Sorry, minus becomes plus when it comes to the other side. Right, then 122, 20 cancels, H equals 20 meters. H equals 20 meters. This is not a new part. This is not a new part. Right? So in first part you have a new application, but in the second part that is not a new question. That is not a new part. Raise your questions if anything. Right? Raise your questions if anything. The ones on Zoom and YouTube both. Right? I'm looking at the chat boxes, so you can raise anything if there's anything. Right? Okay. 3. Time taken to B to reach ground. It should be time taken by B. Time taken by B to reach ground. To find time taken by B to reach ground, that is also very easy. Apply an equation for B. For B from S to T. From S to T. From S to T. From S to T downwards, we need time now. What is known? Distance is known. Right? Then use S equals UD plus half AD squared. S is 10. U is 0. Half A is 10 plus 10 now. Applying downwards now. T squared. Right? Because throughout the motion, you have gravitational acceleration. No? 10 equals 5t squared. 5 to 10 cancels 2. Then t squared equals 2. T equals root 2. Root 2 is a known value. T equals 1.41 seconds. 1.41 seconds. T is a known value. 4. After B reaches to ground, how many seconds later A will return? Now both of them started at the same time. No? See, both of them started at the same time. Now B reaches the ground when T equals 1.41. Then if we find the total time of A, the difference will be the difference between those two times. No? Then my next target is determining the total time spent by A to reach ground. Right? That calculation I discussed before. We discussed that calculation before. Apply an equation from for A, no? From all the way from A to, sorry, all the way from P to the final point. P to the final point, from P to P, right? P to P. Upwards, S equals UD plus half AD squared. Right? From P to P again, na? S is 0, U is 20, T, applying upwards. So this is minus G, minus 10, T squared. Take it to the other side. Minus 5 means 5T squared equals 20T. 1T to T cancels. T equals 4 seconds. T equals 4 seconds. T equals 4 seconds. So therefore, the delay of A is, right, very easy now. Therefore, delay is delta T. Delay is delta T. Delta T is 4 minus, this time, 1.41. Right? So that is 2.59 seconds. So which means after B reached ground, A returns to ground 2.59 seconds later. A returns to ground 2.59 seconds later after B reaches the ground. Right? A comes to ground 2.59 seconds later after B reaches the ground. After B reaches the ground. Okay. Any questions on that? Any questions on that, students? Tell me it's clear if that is clear enough. Any questions? Any questions? So is it clear? This is also a meeting question. Only difference is this is opposite directional. Opposite directional. Right? These two are coming from opposite directions. There is an opposite directional meeting. Is it clear enough? Is it clear enough? Once on Zoom, at least put a thumbs up or say clear. What about the YouTube ones? You all are clear? For you? Clear? Okay, write down below with a red pen. Write down below with a red pen. Initial separation of objects. Initial separation of objects. Initial separation of objects. Initial separation of objects is equal to. Initial separation of objects is equal to the sum of displacements. Initial separation of objects is equal to the sum of displacements. Initial separation of objects is equal to the sum of displacements of each object. When two objects are meeting in opposite directions. When two objects are meeting. When two objects are meeting in opposite directions. When two objects are meeting in opposite directions. Right? So how is A plus SB equals 10? Yeah, that's what I just explained. Now initially, see, if one object is here and if the other object is here and now they are separated with, say, with a distance h, they are separated by a distance h, right? See, say they are separated by a distance h. Now if they are meeting each other, that meeting is somewhere in between this line. It should be somewhere in between the line, right? At a middle point of the line. So if they meet this point at this point, now from this side, this object should travel this part. From this side, this object should travel this part. Then only they can be at the same point. Then only they can be at the same point at the same time, right? If that is not equal to that sum, which means still they have a gap between those two. If they are meeting, they should be at the same point, no? So it is like this. Say again, you are going to meet one of your friends and both of you are 100 meters away, right? Both of you are 100 meters separated by each other and you are going to meet at some point in between, right? Let's say you are traveling 30 meters from one side and the other person should travel 70 meters from the other side to meet at your point, no? Isn't it? If that person comes 30, the other person should come 70. If you are 100% separated, say one person is coming 40 meters, then other one should come 60. If one person comes 50, the other one should also come 50. If one person comes, say 55, the other one comes 45. So then only they meet. That's the point. That's the logic. That always happens in opposite directional meetings. This is opposite directional. It always happens in opposite directional meetings. Is it clear now? Afil. Clear? Okay, listen. Now from here, all the calculation type questions in linear motion are finished. All the calculations, right? And the next part coming up is one of the most critical parts and very frequent popular part when it comes to questions. That is linear motion graphs. Now we have just finished linear motion equations and we are to start linear motion graphs, right? So now we'll get a break of 20 minutes, enough now, right? We'll get a break of 20 minutes. You can go refresh yourself and have something and come back again. Now it's 12:05, right? Now it's 12:05. So come back to the class by 12:25, right? So this is the break. 12:05 to 12:25, right? So be there at the class by 12:25 again. Be there at the class by 12:25 again, right? All right then, have something and come back. We'll meet again. We'll regroup again at 12:25, right? Right. Okay, I'm audible again, right? Audible now? Right. Listen now. Listen. Right. So now we are moving on to the next part we have in linear motion. Right. That is linear motion graphs. Right. Linear motion graphs. So before jumping into linear motion graphs, right? Listen, before jumping into linear motion graphs, first there are some general things you should know about graphs. Right? There are few general things, general knowledge about graphs. Right? First, quickly we will see the general things about a graph as gradient, intercept, and gradient types, right? Positivity and negativity of a gradient, those things. And then we are going to go on to linear motion graphs. In linear motion graphs, we will be focusing mainly on two things. One is plotting linear motion graphs, plotting and conversion actually. Plotting in the sense plotting and conversion. That's the first thing. And second one is calculations using motion graphs, right? Calculations using motion graphs. Those are the two things. Okay. First, this is about the background knowledge you should know about graphs, right? So I will discuss this as a note. Write down as a note. Write down as a note. Gradient of graph. Gradient of graph. Right now, these are random graph. See, between y and x axis. Between y and x axis. These are random graph. Right? This one. Gradient of a graph is defined like this. Always in maths, angles are measured in counterclockwise direction. So therefore, standard direction of measuring angles is counterclockwise. Standard direction. Standard direction of measuring angles is counterclockwise. This is standard direction. So therefore, all the angles are measured in counterclockwise direction only. If you are doing maths, you know this already, right? So if you are doing bio, just know that angles in maths are measured standard direction. Standard direction of measuring angles is counterclockwise. Counterclockwise. Like this. Right? A gradient is defined as the tan value of this angle. Tan value of the angle measured with the horizontal axis. X-axis, horizontal axis is called the gradient. So therefore, see, gradient of graph we denote by simple lim. Gradient of graph is defined as the tan value of this angle. But using triangles we know, look at the board. Using triangles we know, this is the difference of y, no? This is the difference of values of y. And this side, this is the difference of values of x. This is the difference of values of x. So therefore, tan theta can be written as opposite side to adjacent side, no? Tan theta. Tan theta can opposite side to adjacent side. So therefore, this can also be written as delta y over delta x. Right? So if you have got used to y over x in O levels, right? That is not y over x, right? Now from here you have to know from here onwards, you have to know the exact correct thing. That is delta y over delta x, not just y over x, delta y over delta x. delta y over delta x. Right? So therefore, there are only two ways that you can write a gradient, either as tan theta or as delta y over delta x. Right? Take this down and highlight this. Take this down quickly. Take it down. Right? Okay, next. Listen, next thing is about the signage. About the signage of a gradient. Right? Write down as a next heading, sign of a gradient. Sign of a gradient. Sign of gradient. Sign of gradient. Sign of gradient. It is like this. If this angle with the horizontal axis is an acute angle, see, something like this. If this is an acute angle, like alpha, let's say, if this angle is acute, it is a positive gradient. Right? It is a positive gradient. The reason to come as positive and negative that way is because of the tan value, because gradient is tan theta. Tan values up to 90, tan values up to 90 are positive. Tan values beyond 90 degrees are negative. That's why, right? So you know this already if you are doing combined maths. And for an angle like this, obtuse, say beta, right? Obtuse, it is negative, minus. Take it down. Take it down. So if this angle measured with horizontal direction is an acute angle, that is a positive gradient. If there is an obtuse angle, that is a negative gradient. Right? Next heading is gradient types. Gradient types. Types. Gradient types. Right? So here in this single graph, I'll be discussing all the gradient types we have. All the gradient types we have in the world. These are the all gradient types exist in the world. See? So I'll draw all the types on the same graph. With these separators. So checking a gradient means checking the tan theta. Checking gradient means checking tan theta. Checking gradient means checking tan theta. Right. Look at here and listen. Look at here and listen. Now, for the first part, see the first curve. For the first curve, now I will check for like 1, 2 curves and write the other things, right? So what you can do is you can check other values at home if needed, right? This is how this is going to check. So if you need to check the gradient of this curve, right? See, check this angle throughout the curve like this. See, now here the angle is like this one. So you can clearly see, the value of the angle increases. See, value of the angle increases, and yet there is an acute angle. Since that angle is acute, there is a positive gradient now. See, since that angle is acute, there is a positive gradient, but the value of angle increases, which means tan theta increases. So when tan theta increases, gradient increases. That is called a positively increasing gradient. So that is how the gradient type is derived. So therefore, this is called a positively increasing gradient. This is called a positively increasing gradient. Is that clear? Now, if you check for the second one, see, this angle remains same throughout. This angle remains same. That is an acute angle. Therefore, that is positive. Since the angle is same, that is a constant value. So therefore, this is positive and constant. Right? So likewise, you can check all these ones, and this is positively decreasing, negatively increasing, negative constant, negatively decreasing, and these two are again two special ones. Horizontal means angle is zero, no? Angle with horizontal is zero of horizontal line. Then tan zero is zero. And for the vertical line, angle with the horizontal is 90. Tan 90 is infinity. Therefore, this is how the gradient types differ. We need all these gradient types and the values in the sense signage, type, and the value for our graph plotting and conversions. Right? So that's why you should know this before moving on to linear motion graph. Take it down. If you are using different colors, you can use different colors and show it accordingly. Take it down. Right? Finish. Finished? Okay, now let's move on to our thing, linear motion graphs. Take down the heading as linear motion graphs. Take down the heading, linear motion graphs. Linear motion graphs. Linear motion graphs. Right. So there are three types of linear motion graphs we have, right? ST, VT, and AD. ST means displacement time, VT velocity time, and AD acceleration time, right? So you have all three graphs, and you have conversions from all three types, right? You have conversions from all three types. You have all three graphs and the conversions from all three, right? Okay, so let's see one by one. First one, write down displacement time graphs. First one, displacement time graphs within brackets ST. Displacement time graphs within brackets ST, right? This is a variation between displacement and time. Time is always considered to the or taken to the x-axis, right? So in a graph, there are two main things that we are checking. In a graph, there are two main things that we are checking on. One is gradient, and the other one is area. Right? Listen. If you need to check gradient of a graph, I'll be writing this here. If you need to check gradient of any graph, right? Gradient of any graph is delta y over delta x, no? Delta y over delta x. And if you need to check area of any graph, area is given by y into x, multiplication of x's, right? Just know this before moving on. Gradient you already know now. To find the gradient, that is delta y over delta x. If you need to check the area is the area surrounded by the graph, no? So therefore, that is the multiplication of axes, x into y or y into x, right? Okay, now if I check the gradient here, gradient of this one, gradient of st is delta y. As delta y, I have delta s over delta x is delta t. Delta s over delta t is a velocity. Therefore, first thing is velocity is coming from the gradient of the graph. Velocity is derived. And if we check area, st comes, there is no meaning for st. So therefore, we are not going to write the area here in this particular graph because there's no meaning. Right? Take it down quickly. Right? Write down below with the red pen. Write down below with the red pen. Gradient of st. Gradient of st like this. S slash t. Gradient of st. Write down. Gradient of st gives. Gradient of st gives velocity. 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 Right? Next one, velocity time graphs. Velocity time graphs. Vt, velocity time graphs, Vt. Velocity time graphs. So again, we are going to check on these two. Gradient of Vt. Gradient of Vt is delta V over delta t, no? Right? Rate of change of velocity. This is a known quantity. That is acceleration. That is acceleration. And if you check area here, area is V times t. V times t. Velocity into time is a displacement. S equals ut, no? S equals ut. Velocity into time is a displacement. So therefore, from here, displacement comes. So both parameters are meaningful. Both parameters are meaningful. One is displacement and the other one is acceleration, right? Take it down. Take it down. Take it down. VD graphs. Okay, write down below with a red pen. Gradient of VD, write down below with a red pen. Gradient of VD. 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 Gradient of VD gives acceleration. Gradient of Vt gives acceleration. Gradient of Vt gives acceleration. Second point, keep using red. Area of Vt gives area of Vt. Area of Vt gives area of Vt. Area of Vt gives area of Vt gives displacement. Area of Vt gives displacement. Right. Next one. Acceleration time graphs. Acceleration time graphs. Acceleration time AT. So these are random AT, acceleration time, right? So you can check gradient of AT is delta A over delta T. There is no single term for this. This is called rate of change of acceleration. This is called rate of change of acceleration, right? And if you check area, area is A into T, acceleration into time is a velocity. V equals U plus AT, no? V equals U plus AT. So AT is a velocity. So that is a velocity. Take it down. Take it down. Take it down. Okay, write down below with the red pen. Write down below with the red pen. Gradient of AT. Write down. Gradient of AT. Gradient of AT. Gradient of AT. Gradient of AT gives. Gradient of AT gives. Gradient of AT gives rate of change of acceleration. Gradient of AT gives rate of change of acceleration. Gradient of AT gives rate of change of acceleration. Gradient of AT gives rate of change of acceleration. Next point, keep using red. Area of AT. Area of AT. Area of AT. Area of AT gives velocity. 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 Okay, right. Now let's move on. Right. Go to first graph given in the tube. Go to the first graph given in the tube task to convert. Go to the first graph given as to convert first one. This kind of a ST is given. And in that given one, these sides are not equal, right? So, which means it is like this. Sides are not equal. Something like this. This is given. Not equal sides. Right. So, you are also convert this. Listen. Since this is the very first graph conversion you are going to do, right? Listen. Since this is the very first graph conversion you are going to do, I'll explain a bit. Right? I'm going to explain a bit. And then I will let you do the coming conversions by your own. See? Now, first, we are going to convert this to the respective VT. We are going to convert this to the respective VT. Right? Like this. You are going to convert this to the respective VT. Respective VT. What is the relationship between ST and VT? ST and VT. ST and VT. There is only one relationship. That is this. Gradient of ST graph gives velocity. Gradient of ST graph is velocity. See how this argument is done? If ST graph is given, which means gradient of ST is known, right? If ST graph is given, which means gradient of ST is known. So knowing this, you are going to get velocity, right? So this arrow is just to show you the direction that you are going to build up this argument. Show you the direction that you are going to build up the argument. Knowing this, now we know this one. You know this one. Knowing this, you are going to get this. Knowing this, you are going to get this, right? So which means what you need to look at is the gradient. What you need to look at is the gradient. Gradient of given ST. See? Now, this is where the gradient types you learn comes into play. This gradient is positive constant. This gradient is positive constant. This gradient is 0. And this gradient is negative constant. This gradient is negative constant. Right? Now, then, if this is a positive constant gradient, see, there are two things of a gradient. No? there are two things about a gradient. They are, one is sign. There are two things about a gradient. One is sign, and the other one is the behavior. Behavior in the sense whether it's increasing, decreasing, or constant. That is called the behavior. Sign is whether it's positive or negative. Sign is whether it's positive or negative. And the behavior is whether it's increasing, decreasing, or constant. Right? So that's it. Those are the two things you need to look at. So look at those two separately. Consider those two separately. See, first one. There is positive. Positive gradient. If there is a positive gradient, we know velocity should be positive. If there is a positive gradient, velocity is positive. If the gradient is constant, velocity is constant. So therefore, here it is going to be a positive constant velocity. It is going to be a positive constant velocity, something like this. A positive constant velocity. Right? And next one, second time interval. Gradient is 0. If gradient is 0, velocity should be 0 because gradient equals velocity. Then at this part, velocity is 0. Velocity is 0. Right? And here, negative and constant. If the gradient is negative, velocity is negative. If the gradient is constant, velocity is constant. So which means there is going to be a negative constant value. But there is another thing that you need to check. That is, we know if slope is higher, gradient is higher. If slope is higher, gradient is higher. Because as tan theta, gradient is also delta y or delta x. Higher the slope, higher the gradient. We can clearly see this slope is higher. This is a higher slope. Even though there is negative, the slope is higher. Delta y or delta x. This is delta y or delta x. Can you see? This one over this part is greater than this part over that part because this value is greater. Denominator is greater, so value is lesser. Got the point? Therefore, this gradient is higher in magnitude compared to this. So everything is correct that we know that is negative and constant. That is negative and constant. But the magnitude of this gradient is higher because there is a higher slope. There is a higher slope. So therefore, now for this velocity, I have used this much of a height now. For this one, that should be greater than that. It should be, this height should be greater than that because value of the gradient is higher here. Value of the gradient is higher here. Got the point? Now, as an example, if I explain this by using these two angles, right? If I explain this using these two angles, tan beta is greater than tan alpha. This is what I said. Tan beta is greater than tan alpha. Since tan beta is greater, gradient is also greater. Right? I know sign and behavior, everything. The value is greater. Right? So this is the converted Vt of this St. This is the converted Vt of this St. Right? Take it down. Raise if any questions. This is the first question we discussed. First conversion, no? First conversion. This is the first conversion we discussed. Go to the second one. Go to the second conversion. Second one. Try the second conversion. Second conversion. Another ST is given. Another ST is given. If the shape is not clear, I will draw it here again. And for the second one, we will be converting this ST to both VD and AD. Right? You will be converting this ST to both VD and AD. To both VD and AD. Right. See? And try this before I start. I will give you 2 minutes. Try to convert this for both VD and ST, for both of them. Try to convert for both VD and AD, both of them. Try to convert for both of them. ST, VD, AD. Right? Right? 2 minutes. Try it out, 2 minutes. Right. Right. 2 minutes. So that is where the gradient types and behaviors comes into this. This is where it comes into this. Right, next one. See? Again, the relationship between these two is gradient of ST is going to be velocity. Now, if the ST is given, gradient of ST is known. So, knowing that, you are going to get the velocity. Right? So, this gradient is positive constant. This is a zero gradient. And this is negatively increasing gradient. Negatively increasing gradient. Right? So, this should be positive and constant. If gradient is positive and constant, velocity is also positive and constant. Right? If gradient is 0, velocity is 0. If gradient is 0, velocity is 0. Right? And here, if velocity is negative, if gradient is negative, velocity is negative. And the gradient increases. Gradient increases, then velocity should increase. Increasing the velocity means the value should increase. Sin B anyway, no, sin is negative. Sin is negative and the value should increase. Sin is negative and the value increases. So sin is negative here and that value increases. Right? So finally you can connect these three. Finally you can connect these three like this. Right? This is important. This is important. Negatively increasing means, so that is what I told you. That is why I told you. Look at those two as two different variables. First sign and then the behavior. Sign is about the sign. Behavior is about the magnitude. Sign is about the sign. Behavior of the gradient is about the magnitude of the value. That's the magnitude. Magnitude, no. Positively increasing means sign is positive. Increasing means value increases. So negatively increasing means sign is negative. The value increases. The value increases. The sign is negative and the value increases. Like this. Right? Then you can convert it to AD. To convert to AD, you have to know the relationship between VT and AD. We have a relationship. because gradient of Vd is acceleration, isn't it? Now, since Vd graph is known, gradient of Vd is known. Since Vd graph is known, gradient of Vd is known. Right? Now, check the gradients here. This gradient is 0. This gradient is 0. This gradient is negative constant. Then 0 acceleration, 0 acceleration. This is a negative constant acceleration. Right? 0 acceleration, 0 acceleration, and a negative constant acceleration, because gradient of Vd graph is the acceleration. Gradient of Vd is the acceleration. Right? Take it down and ask if any questions. Take it down quickly. So if you finished it, try question 3. If you have finished already, try question 3. Try the third one. The shapes are not clear enough. You can check with my diagram if there are any doubts. These separators are drawn to you to see the correct shape correctly, the correct shape and the section, the time interval correctly. I'll start in a minute. So try this. I'll start in another minute. So you can raise if any questions. Okay, let's see. Okay, same relationship, gradient of st is velocity. So check this gradient. This gradient is positively decreasing. This gradient is positive constant. This gradient is negative constant. This gradient is negatively decreasing. Negatively decreasing. See, gradient is positive, which means velocity is positive. And gradient decreases, means velocity decreases. So then velocity decreases, starting from somewhere here, velocity decreases. Velocity decreases. And if you check the second part, in second part, that is a positive constant value, no? Which means velocity is positive constant. So therefore, that is not going to decrease up to 0. It remains as a positive constant value. It remains as a positive constant value. And this part is negative constant. So that is on the other side, negative constant. And here, negative and decreasing, right? Negative and decreasing. Value is negative. Value is negative. And the magnitude decreases. Magnitude decreases. So it comes somewhere here. It decreases. Right? So likewise, you have to check it one by one. Time interval to time interval. Check it one by one. From time interval to time interval. And then only you can plot the correct graph. And when these questions are coming as MCQs, the other possible mistaken graphs are also given. So therefore, without knowing the exact thing, right, you won't pick the correct answer. Right? So therefore, this is critical. Then the acceleration time, same thing. Gradient of Vt is acceleration. Gradient of Vt is acceleration. Right? Then, since Vt is known, gradient is known, we can get the acceleration. See, this is negative constant. This is 0, 0, and this gradient is positive constant. So the acceleration graph is negative constant here, a negative constant here, and these two, both of them are 0, and a positive constant here. Got it? Okay. Any questions so far? Is it all clear? Is it all clear? Or any questions so far? Is it all clear or any questions? Quickly. Right. I feel clear. Others? Hamza, Shani? How about you? Okay. Listen now. Listen. Listen now. I will keep the coming two questions as homeworks. Question 4 and 5. Keep question 4 and 5 and 4 and 5. Keep question 4 and 5 as homeworks. And now let's go to question 9. 9 and 10 are the questions, essay type questions, essay type questions using graphs to solve just by using the graph without using the equation. Right? Okay, now go to question 9. Keep the other two conversions as homeworks. Keep other two conversions as homeworks. Right. Go to question 9. Read the question and start it. Because in first part, it is asked to plot a VD, no? It is asked to plot a VD. Try to plot the VD graph. Try to plot that VD. Right. Question 9. Question 9. Question 9. A bus starts its motion from rest at point A and accelerates with 5 ms minus 2 for 6 seconds, and it continues its motion with gained velocity for another 10 seconds. Now brakes are applied in order to stop the bus in 3 seconds at point B. Bus waits for 5 seconds at that point. Waits for 5 seconds at that point. Okay. Right. Now, since the first question is about plotting a VT graph, while going through the question, you can plot the VT graph. Right? While going through, you can plot the VT. While going through the question, you can plot the VT. Right? Since conversions are also asked, right? I will plot my VT somewhere here for ease of my explanation. Nah? This is for the ease of explanation. Without plotting VT here, because I'm going to convert this to ST later on in the second question. So therefore, I'm going to plot my VT here. See? First, give it a try. First, try to plot VT. I will give you a minute and we'll start in a minute. Try to plot VT. Try plotting VT. Try plotting VT. Right. A bus starts its motion from rest at point A. From rest at point A and accelerates with 5 ms minus 2 for 6 seconds. Right. So it accelerates starting from rest, which means velocity, initial velocity is 0, and accelerates with 5 ms minus 2. No? See? For 6 seconds. Now here you have to put these units, seconds, and V is in ms minus 1. Putting the unit is mandatory. For 6 seconds here. And gradient is 5. I will mention it here, 5 ms minus 2. And continues the motion with gain velocity for 10 seconds. Right. Now, this gain velocity is, we don't know the value yet, is continued for another 10 seconds. Then here it should be 16. It should be 16. Right? Should be 16. And then, now brakes are applied in order to stop the bus in 3 seconds at point B. Right. Then in 3 seconds, it should be stopped. So in 3 seconds, right? In 3 seconds, then this is 19. And bus waits for 5 seconds at that point. Then from 19 to 24, it waits. No velocity. From 19 to 24, it waits. So this should be the basic VT graph that you should get. That is a basic VT graph that you should get. And in the second question, it is asked to convert those graphs. Convert above graphs to respective ST and AT. You have to convert this to ST and AT. Right? Both. Both. Right now. For part 1, this is it. And now we are going to convert. I'll draw the AT here. I will do the AT here. AT here. And I will draw the SC here. SC is in meters. This is in seconds. A is in ms minus 2. Right? Right. Right. Right? Okay, let's see. Let's see. First, I'll do the AD conversion. AD conversion. See, what you know is gradient of PD is A. Knowing the gradient of PD, you can get A. See, now this is a, I'll be writing here positive constant gradient. This is a zero gradient. And this is a negative constant gradient. And this is a zero gradient. Then the acceleration is, this is a positive constant acceleration. Positive constant acceleration. Right? Then zero acceleration. Negative constant acceleration. But we know this slope is higher. It is very clearly visible. No? This slope is higher. Slope is higher. So therefore, this acceleration is, that is negative and constant, that is true. The magnitude should be higher. Magnitude should be greater than this. A greater magnitude than this, like this. And finally again, zero. Zero means velocity is zero again. The acceleration is zero again. Not the velocity, acceleration is zero again. So these are respective AD. These are respective AD. Now this value is known. This is given as 5, no? So this is 5. This acceleration was given 5. And times are same. 6, 16, 19, 24. And ST conversion. See, now in ST there is a difference. Look at the board. We are going to convert the other way, backwards. What we know is gradient of ST is velocity. Now velocity is known and you are going to get the gradient. What the point? That's a backward conversion. You are going to do the conversion in the opposite direction. We are going to do the conversion in the opposite direction. Right? Gradient of ST is velocity, that we know. But now what we know is velocity. Knowing the velocity, we are going to get the gradient of ST. See, now there is no point of checking gradient of velocity because we need velocity. Velocity means that is about the value of velocity. Value, the true value, not the gradient, the value. See, in this first part, gradient is positive. Gradient is positive. I'm checking at the value. Value increases. See, value increases. value of velocity increases. Value of velocity increases. Whatever happens for the velocity should be happen to the gradient of st now. So therefore, this gradient of st should be positive when increasing, isn't it? Right? Explaining again. Listen, explaining again because you are doing a backward conversion for the first time here. You are doing a backward conversion for the first time. So this is a backward conversion. Knowing v, not gradient of v, this is v, velocity. You should know the velocity. Knowing velocity, you are going to get the gradient. You are going to find the gradient. Knowing velocity, going to find the gradient. Knowing velocity, going to find the gradient. Velocity means this is about the actual value of velocity, not a gradient. Gradient about the velocity. Now this velocity is a positive velocity, but this velocity is increasing its value, which means gradient should also positive and increasing. Right? And about this part, this velocity is also positive. See, this velocity is also positive. That velocity is also positive. But value of the velocity is constant, which means value of the gradient should also be constant. Right? This part, this velocity is also positive. This velocity is also positive in this line. Positive. But the value of that velocity decreases when it comes from here to here. Value decreases. Value decreases from here to here. Value decreases. And here, velocity is 0. If velocity is 0, gradient is 0. If velocity is 0, gradient is 0. Right? So that is how, listen, that is how you should argue. That is how you should argue. Got the point? Now, plot these gradients. Plot these gradients. That's it. Positive and increasing. Something like this. Positive constant. Like this. Positive decreasing. Positive decreasing. Positive decreasing. Like this. And 0 horizontal. Right? So that is called a backward conversion. We converted the graph in the opposite way. Now, if you need to make sure, listen. If you need to make sure, try to convert this ST and check whether this VT comes. If it comes, it is correct, no? That also you can do. See, this gradient is positive constant. So, sorry, positively increasing. Then velocity is positive and increasing. Correct. This gradient is positive constant. This velocity is positive and constant. This gradient is positive and decreasing. This velocity is positive and decreasing. 0, velocity is 0. Right? Like that. Take it down. So this is a new part we did. A backward conversion. This is a backward conversion. Right. Part 2. Part 2. Part 2. Convert above graph to, that's done. Part 3. What's the maximum velocity gained by the bus? That is here. Maximum velocity is here. No? Since we are going to find this out, I'll label this as U. Listen. If graphs are given, listen. If graphs are given or if graphs are available, then hereafter you are restricted to use equations. Listen again. If graphs are available, if graphs are given to you, or if graphs are available, using linear motion equations are prohibited. Using linear motion equations are restricted. So therefore, you have to solve the question, solve the entire thing just by using the graph. You have to solve this entire thing using the graph. That's it. Right? I equations use karana bad. If you have the graph, you can't use equations. Right? So therefore, now to find this u, you can't use an equation, use the graph. See, this is how we use graphs. These are we use graphs to find this out. Listen. If you are mentioning about a gradient, mention the angle. See, now since I need to mention about this gradient, I am labeling this angle as alpha. Label that angle as alpha. Right? And then, see, we can write this way. This is how we are writing this using the graph. Gradient equals tan alpha, isn't it? Gradient equals tan alpha. No? Gradient equals tan alpha. And tan alpha can be written as this whole height is u over this distance is 6. U over 6. Right? We know gradient of VT graph is 5. There is acceleration. That is 5. So therefore, 5 equals u over 6. U equals 30. See how easy that is? So always using the graph when solving questions is easier compared to equations. Right? That is why you are not allowed to use equations if the graph is available. This is how you should present your answers. Mark the angle since you are going to use it here and present your answer this way. Right? Next one. Take it down quickly. Third one, part 3. Then part 4. What's the distance traveled with uniform velocity? Part 4. What's the distance traveled with uniform velocity? What's the distance traveled with uniform velocity? Right. So we know uniform velocity is from here to here. Uniform velocity is from here to here. No? It is from here to here. Distance or displacement in a VT graph is given by area. Distance is given by area. Right? So since we are going to write this area, see, I'm going to label this for my ease. Say this is O. Say this is O. Right? And A, B, let's say C, D, E, and F. For me to identify these ones. Right? So what you can say is displacement with distance traveled with uniform velocity, no? Then you can say distance or displacement with uniform velocity equals area under what? Sorry, not under, area of killing, area of ABFE, area of ABFE rectangle, area of ABFE rectangle, right? ABFE rectangle. What's the distance traveled with uniform velocity? Area of ABFE rectangle, that's it, right? So find it out. Area can be written as this side is U is 30, U is 30, and this is 16 to 6 to 16, 10. That is 300 meters. Very easy. 300 meters. Very easy. Right? You should know the correct theories. If you know correct theories, doing the sum is easier. The sum is easier. Right. Five. What's the value of deceleration bus head? Right. Quickly. Right. Now here in the very last part, latter part of linear motion now, right? So try part 5. Try part 5. We are in the last part. Now you should get your own answers, right? We are in the last part. You should get your own answers. What is the deceleration bus head? Have proper presentation, proper representation of the answer, or the presentation of the answer with correct logics and everything. Logics, labels, everything. Right? If you need to find the deceleration, right, we have to deal with this angle, this gradient. So therefore, I'll label this as beta. I'll label this as beta. Then write tan beta. So you can say gradient equals tan beta. Gradient of this part of the curve is the deceleration, no? Because it decelerates from here to here. From this velocity to 0, it decelerates. So gradient of this curve from here to here is the deceleration. Simple as that. Then m equals tan beta, and you can write this gradient as u over 3. You can write the gradient as u over 3. Right? And we know this gradient is the deceleration. Right? I label that deceleration as a dash equals u is 30. U is 30 over 3. Right? 30 over 3. So it says a dash equals 10 ms minus 2. A dash equals 10 ms minus 2. Right? Now, when you deal with the graph, sign doesn't come. Right? Then finally you have to put the sign, because you have the graph here now. By looking at the graph, you can get the sign. These are positive gradients. These are negative gradients. So there is a negative gradient. Since there is a negative gradient, you can put the negative sign manually, or else, since the deceleration is asked, it is not compulsory, it is not a must to put the negative sign, because deceleration is asked. Right? Negative acceleration is a deceleration, no? So therefore, deceleration is asked. Deceleration, value of deceleration is 10. Right? So if needed, you can mention this way. Therefore, deceleration equals minus 10 ms minus 2. That's it. Next one. What is the distance between points A and B? 6. What is the distance between points A and B? Distance between points A and B. Any answers? Quickly. Distance between points A and B. Right? Easiest way is, if I need the distance between points A and B, right? Then B is here, no? B is here, no? According to the question, starts at A and ends at B. Get the total area under this curve, under this polygon, trapezium, right? My argument is displacement between A and B, SAB equals area of OABC. OABC. Area of OABC trapezium. At once you can get it using the trapezium. Right? Area of OABC. Very easy. Then parallel sides are 19 plus here 10. 19 plus 10. 19 plus 10 over 2. Whole thing into perpendicular distance 30. Right? 29 times 15. 29 times 15, 435, right? 435 meters. 435 meters. Determine the average speed of the bus in above motion. Average speed. Average speed. For average speed, there is an equation. There is an equation. What is the equation of average speed? You should know this. Average speed. Equation is total distance over total time. This is called the average speed. Total distance over total time is called average speed. If you need total, if you need average velocity, that is total displacement over total time. Average speed is total distance over total time. Average velocity is total displacement over total time. Right? That's just a simplification. Total distance is here 435. Total time is, this is important. Total time is not 19. Total time is 24. Even though it is at rest, that is part of the motion. If an object is rest in a motion, that is part of a motion. So therefore, that is not 19, that is 24. Right? Find this out. Find it out. What's that? What's the value? $18.125. 18.125 ms minus 1, or else you can keep this answer as 125, no? 18.13, that is also fine. ms minus 1. 18.125 or 18.13. $435, correct. Good. 10 is also correct. Okay, any questions on this? Any questions? Is it clear? Is it all clear? Rod, you, is it clear? Is it clear, students? Okay. Right. Okay, no questions, no? No questions. No questions, right? All right. Listen now, listen. And you have to try question 10 also as a homework, the last question in the tube. Right? You have to try question 10 also as a homework. Right? And hereafter there are few more things. Listen now. Listen. Now from here, linear motion is completed, is 100% completed. In linear motion, we have linear motion equations and applications of linear motion equations, linear motion graphs and conversions, right? So all parts are being finished now, which means now just by this first day itself, all the parts of linear motion is finished, right? All the parts of linear motion is finished. And next day, we'll be taking the entire day for projectile motion and vectors. The next day, we'll be taking the entire day for projectile motion and vectors. Projectile motion and vectors. Projectile motion and vectors. Right? So in this class, we'll be covering the things in a kind of a faster manner. And as I told you at the beginning, the reverse class is also going to start in January. And then you will be covering 2 different units in a particular week. That is how we are going to cover it up. Right? Okay, listen. Then there are 2 homework questions. Right? One is a graph conversion. Actually, 3 homeworks because 2 graph conversions are there. 2 graph conversions and the last question here. Last question in the review. Right? Plus, there are a few more things. All the past paper questions from linear motion I have included in the tute. I have put in the tute. Right? So now what you can do is, you can try all the questions from past papers and I'll be giving you the answers for past papers. Giving in the sense, I'll be uploading the answers for the past paper questions I have given in the tute to the website. Right? So by next week, in my website, on my website and LMS, these ones will be available. The answers will be available. All right. So if any questions you can ask now before winding up. Is there anything? Is there any more thing? Anything to know? And listen, about the registration, about the registration. For online students, registration is done only through the website, no? So that you all know if you are participating already through the website today, right? If not, what you can do is you can visit the website psphysics.lk, right? psphysics.lk. You can visit here. You can visit here and create the account. Visit here and create the account, and you can enroll yourself by your own, right? Okay. You can enroll yourself by your own, right? So if any questions, if you need any assistance regarding this when you are doing the enrollment, doing the registrations, you can contact me. Feel free to contact me, right? Otherwise, you can do it by your own, right? Okay then. No, any questions? No? All good. Good. Very good. Okay. If there's no questions, we'll wind up. So this is the first day of the revision we had. So in the second day, as I told you, we'll be starting projectile motion and vectors, right? Okay then. Then we'll wind up the class here. See you all in the next class, right? So complete your registrations before next week because for online students especially, registration is joining to the class is done through the website only next week onwards, right? For the physical students, that doesn't matter. You can do the registration at the institute itself. And we are going to have the next revision at Mashma Bambalavidia tomorrow, right? It will be the same content, exactly the same content, and no online classes there for tomorrow, right? That is only the physical class. So the revision, second day of revision at the other institute will be tomorrow, right? Okay then. Then study hard and work hard. See you all in the next class. Goodbye. Afil, drop me a private message, right? I'll send you. Drop me a private message. Okay, goodbye.